Okay then, so now we can finally start updating the UI. So let's start with the main scene. Inside the main scene here, we have this high score label, which is what we want to update. Let's open the main scene script. And then what we can do is do a control drag of the high score label. Not there, that's not very good, is it? Let's try that again, please. Okay, good. So we've got the high score label, or the label high score. What we want to do is actually directly update this as soon as this scene loads. So we can take the label high score dot, and then we want dot text, and that's equal to, and then we'll have a high score space, and then we can add on, and then we want a string, and we want to get hold of our score manager dot get high score. Control and S to save. So now if we do F5 to run the game, we have the high score of 19 on the screen, which is good. Maybe actually we could add a colon in here, maybe, so colon and a space. Let's do F5, F6 I've done there by mistake, but it doesn't matter, does it? So we're okay, good. High score and 19, excellent, being loaded from our file. So I can close that down. Next, what we need to do is we need to go into the HUD. So I'll drop down into the HUD. We've got the open up the scene here. And here what we want to do is we want to update our score label. So we'll drag our score label in here, control drag. And again, it's dropped it down there, and I'm not sure why. So I'll try again. There we go. Okay, so we've got the score label. What we want to do here is update each time the score is updated. So you've probably guessed what we're going to do here. We're going to add ourselves a signal here. So we're going to the signal, and we'll make a new signal called onScoreUpdated. We want to emit this from inside our score manager. So I've got the score manager script open here, scoremanager.gd. So we'll do this every time we've updated the score. So we'll do the signal manager .onScoreUpdated.emit. Then what we can do is we can go, we can grab hold of this onScoreUpdated signal manager, go back into the HUD script, and then we can hook ourselves up to this. So we can connect ourselves up, and we want onScoreUpdated. Let's write a new function then just above the onPlayer hit. So we'll do func and onScoreUpdated, and then we can get hold of our score label, and we'll say .text is equal to convert to string, get hold of our, not game manager, sorry, the score manager dot, and we want to get the score. Then I'd like to run the game. As we drop into the game, we should now be able to have an updated score. We do. However, there's one thing that's not quite right, isn't there? If I just do F8 and then rerun again with F5 and go into the game, we've got immediately these 4 zeros at the top here. So let's fix that as well. So where we have the score here, we can use a built-in function called lpad, I think. Yep, lpad. And that allows us to pad to the left of our string to a minimum number of characters, let's say. So what we'll do here, we'll do 5 characters for a huge score, and we'll pad then with 0 and do Control and S to save. If we go back to 2D view actually and drop into our HUD, what we need to do is make sure that we set this score label by default actually to have 5 zeros. So let's do Control and S to save. Now if we run the game with F5, what we should see now, if we drop into this, is that the score updates that much better. Okay, so the score's now fully padded with zeros, which I think is a lot nicer. Anyways, kill the boss if we can. There we go, loads of points. Oh, was there something? Nope. Next level, let's go into the next level. Kill a frog, very good, get the pickup, excellent. So everything now seems more or less to be working. I'm going to do F8 to close that and close down the output. There was one tiny thing I noticed before we finally drop into the design of a couple of levels, and that was the actual time scale. So let's go into script view, search, finding files, and let's find time_scale. I just want to double check that we're setting things sensibly here. So inside the HUD, we're setting it to 0 when we're actually showing the HUD, because that's the game over or something like that. That's correct. Then inside the level base, we're setting this as soon as we're ready to go with a level, the timescale is back to 1. And then inside the main, when we're loading the main screen, the main screen, we're setting the timescale back to 0. Now, I don't think we actually need to do this, do we? So I'm going to delete that line actually and do Control S to save, and then run the game again. Everything looks all right to me anyway. Let's go inside the game. We've still got that camera shake, but I quite like it actually. And we're, oh God, I've fallen off the game. That's okay. Let's, if we go, everything is still in the background. Go back to the main menu, go back in. Let's actually fall off again. There we go. And everything seems to be still in the background. I'm going to do this once more just to go back in again. Try and see if I can actually get the snail here, the pickup. Need something else moving. So that's sort of moving fall off, and it's still as well. Okay, so that all looks all right to me. So that was a superfluous line of code there that we didn't need. What we now need to do is set about actually designing some proper levels. Before we go into the level design, I want to take a little bit of a look again at how we're pausing the game. Throughout the series, I'm going to tend to use timescale and set that to 0 to pause the game. As I've already mentioned, it doesn't actually make a pause of everything. The process functions and things are still being invoked. It's just that the elapsed time is always then 0. There is actually built into Godot a way to completely pause the game, and what I'd like to do in this video is actually swap out the timescale thing that we do for the actual pausing mechanism that's built into Godot, so you can then choose which one you prefer to use. We can take an initial look at this by actually going into the script view in the interface, and by the way, I've closed everything up and all scripts and everything. Inside the search help, I'm going to type paused, and down the bottom here you can see the main loop, scene tree and pause, so I'm going to double click on that. And you can see that if it's set to true, the scene tree is paused. It also says that all 2D and 3D physics will be stopped. This includes signals and collision detection. What that means is the physics process functions will no longer be invoked. To demonstrate this, then what we can do is switch out the timescale stuff for the tree pausing. So what I'm going to do then is go to search here and then to find in files. Inside here, what I'm going to do is type timescale, click find. And then down the bottom here, we've got all of the instances of timescale that we've got inside the game. So we've got it in the HUD.gd and also in the level base.gd. Let's start with the HUD. So I'm going to double click on this here, and that takes us then into the HUD.gd where we're setting the timescale to 0. What we're going to do is we're going to comment that line. Then we're going to type get tree.paused is equal to true. Now what will happen is when the HUD is shown, we'll have almost exactly the same effect as we did before, except the whole tree is now paused. That means no process is called, no input is being processed or anything like that. The whole thing is stationary. So what I'm going to do is grab hold of this line and just copy it. Then double click on the level base here where the timescale is set to 1. Comment out this line here as well. And now set that the pause is equal to false so that every time we enter a level, we effectively unpause. What we're also going to have to do here is actually do this when we enter the main scene as well. So I'm going to scroll at the file system, open up the main folder here, open up the main.gd, and inside the ready function, what we're also going to do here is make sure that we're not paused, and I'll do Control and S to save. Go back to level base, Control and S to save. So our logic should be every time we go into a level, we're not paused. And then if we do have the game over or the show HUD called, then what we'll do is set ourselves into pause mode. And also every time we open up the main scene, we'll also set ourselves as not being paused. What we can do then is we can test this out by playing the game. And I can tell you we're going to have a little bit of a problem with this, which is why I prefer to use the timescale. So I'm going to do F5 to play the game. Inside the game then, I'll go into our first test level and just kill the boss, hopefully. So there we go. And actually what I'm going to do is actually let the boss kill me. So let's let the boss take one more life away and I should die. And now you can see that everything's paused in the background. So we can see that there's no animation going on. It's absolutely everything still in the background, which is great, which is exactly what we wanted. What I'm going to do now though on the joypad is press jump to go back to the main menu. And when I do, the jump isn't working. The reason it's not working is because the entire tree is paused, and that also includes being paused for inputs. So I'm going to stop the game. To be able to have a certain scene or node process input, we actually need to tell Godot we want that to happen even when the tree's in the pause state. The way we do that then is by opening up our HUD scene. So I'll double click on the HUD here. And then what we want to do, I'll go in 2D view because it's easier. Selecting the HUD on the top left-hand side, going onto the right-hand side in the inspector, you can see that we've got this process here. We use this here to tell Godot when we want to be calling process. Now, at the moment, we're saying we're going to inherit this behavior from whatever the parent is. Here, though, you can see that it's pausable, or we call it when paused, or we disable it, or we call it always. In our case, what we want to do is we want it to always be called on the HUD. That's because the HUD needs to process our input to be able to navigate back to the main scene or the next level. So now what should happen when we play the game, if I run up to the boss and then die. So let's run along here and try and get killed by the boss. So there's one life gone. Let's let the other one go. Now I've got the game over, everything's paused, but when I press jump, I've gone back to the main menu. Now I can press jump again and go back into the level again as well. So I'll press F8 to close that down. If I just go back into the main.gd here, If we hadn't put this line in here when we came back into the main scene, what would have happened is we would have still been paused and it actually wouldn't process any input, so we wouldn't have been able to go to a level. The same thing also at the beginning of the level base as well. If we hadn't put this line in here, we would still have been in pause even if we'd advanced to the next level. So although I have a personal preference to usually use time scale because I like the flexibility, you can also obviously use get treed up paused, and I thought it was only right to show you that this feature exists because theoretically it probably is the intended way to pause the games. Now we've been through that, what we can do in the next video then is we can start looking at some of the inspiration for actually building out some proper levels. Now the game Foxy Antics actually came from CJ's Elephant Antics. I grew up, I'm probably a lot older than you are watching this course, and I grew up with the Commodore 64 and the Spectrum, in fact right at the end I would say of sort of the Commodore 64 era, so at the end of the 1980s, and one of my favourite games to play was CJ Elephant Antics. In preparation for Foxy Antics, I actually went back and looked at how CJ Elephant Antics worked, and we've mimicked quite a lot of the features, I think nearly all of the features of CJ Elephant Antics in Foxy Antics. Now, in terms of platformers and gameplay, it's quite interesting for me that since the 1980s, I don't think they've improved that much. I often think with platformers, less is a little bit more. The intriguing gameplay comes really from Jeopardy, so that if you die, you go all the way back to the start of the game, and also trying to work out and learn the maps to be able to progress. So I actually went onto the web and had a look if I could find the map. So I put CJ Elephant Antics maps into Bing here. You can use obviously whatever search engine you'd like, and it came up actually unbelievably with a site that has the maps from the ZX Spectrum. This gave me a little bit of nostalgia, but it's also given me a little bit of inspiration to be able to design one or two levels that I then would like to showcase to you in the next video. So what I'm going to do now, and obviously it's optional for you, is I'm going to try and build out a couple of levels that are sort of meant to be played seriously as a game and have a little bit at what they look like. And if you manage to design something, which I'm sure is miles better than whatever I'm going to do, then I'd really be curious to see yours as well. And please feel free to put them inside the Q&A. So I'll see you in the next video where hopefully there are some interesting levels to look at. Okay then, so I've gone ahead and built a couple of levels. I just want to quickly show you what these levels look like. You can see level 1 on the screen here, which has a few enemies and some tricky platforms to jump up and some channels to go down with some spikes, then some moving platforms over here, and finally the boss section here. We've got some straightforward platforms at the start here. I'm actually going to move the player and make things a little bit easier so you can see the moving platform part up here. So I'll press F5 to run the game. Then I'm going to press the start button and shoot that snail straight away. So you get an idea here of what the level looks like. I think I should land on the platform. Yes, I do. Good. Loads of spikes down the bottom there. And yeah, we're coming towards the end part of the level here. I've actually adjusted a little bit the sort of speeds of the player. I'll show you those in a minute. And also the eagle as well. It shoots a lot more regularly because it wasn't shooting enough. I'm going to hit the eagle here. Well, of course, excellent. You get the idea anyway. I made some adjustments just so it wasn't quite so hard to jump up platforms and things with the fox, and also can't shoot quite as regularly either, and it makes shooting that snail really, really tricky. I've got a button assigned also to advance to the next level, so here we are at the start of the next level as well, just to show you what that level looks like as well. So we've got sort of ball spikes around. I think we've got lots more enemies in this one as well, a much more tricky environment to run around. I'm going to do F8 and turn that off actually. Go to level 2, and where's the player? There's the player. Let's drop the player somewhere else. So I'll drop the player here for now as well, just so you can get a quick view of this as well. Don't want to bore you too much with this. So inside level 2, further on here then, we've got lots going on, more eagles. I've already been killed by a frog. And yeah, it's actually quite difficult, I've realised, at some stages on this as well. If I can get down here with these ball spikes, it requires some amount of planning ahead. You can see I've nearly lost all of my lives already. So I'll close that down. And I think then level 2, yeah, you have to go through some channels and things like that. And then eventually you get into this section with a moving platform. A load of eagles start flying at you, which makes things quite tricky. And finally you land at the boss. What I have noticed, and I'm sure you've noticed as well, is throughout the running of the game, the debugger has been saying, hey, there are some things that you need to fix inside here. These yellow ones aren't serious and not game breaking. Nevertheless, we could take a look at them. So we've got the parameter delta here. This is very familiar to you now, probably. We haven't used the delta inside the process here, so we'll underscore that. Then we've got the area. That's not ordered here, so we'll underscore that, and basically it's a matter of just underscoring things that you don't need. I'm going to delete that print statement from there as well because we don't need that, and then we'll go here as well. I'm just going to quickly go through all of these and edit this as well so it's not quite so dull for you. Okay, I've cleared most of those up. There is a couple here in the enemy base, the gravity and the facing, which aren't used correctly in this script, but they are used in scripts further down, so we'll leave those in like they are. And finally, the other thing I said I'd show you very quickly in the player script here is the values that I just used to clean the player up a little bit or make the movement a little better. So I've got gravity 690, fallen off 100, run speed 70, and the jump velocity minus 260. I found that was a little bit better. Okay then, back into 2D view, and that pretty much I think completes all of the features that I wanted us to implement in this game. In this addendum to this section, what we're going to do is have a look at a little bit of a bug, or a feature, depending on how you look at it, with the boss, and actually being able to shoot the boss. Somebody very kindly pointed out that we can actually shoot the boss, so trigger the hit area of the boss, before the boss has actually been triggered to jump up and down and run at us. On the screen here, what I've done is opened up the original base level, actually, where there were just a few platforms and things, and I've put the boss right in front of the fox, so this is easy to demonstrate. Before running anything, inside the boss itself, inside the script for the boss, what I've done is just in the on hitbox area entered, is I've just put a print statement in here so we can see what is hitting the hitbox area of the boss, and then also for the bullet base, I've also in the on area entered also put print bullet area entered by and then underscore area so we can see what's going on. So going back to the level base and then into 2D view, we've got the fox here and then we've got the boss, which is sitting here. This is the trigger, if you remember, for the boss, and this is where the boss actually will appear, and that blue sort of box there is the boss's hitbox. If I play the game and stand still and don't do anything and then just shoot a bullet, what we'll see is the bullet disappear, and indeed what we'll see down here is that we've got the on hitbox area entered by bullet player, and then we've got the bullet area entered by hitbox. In other words, we are actually hitting and causing damage on the boss before the boss has actually been triggered. Now this is bad for a couple of reasons. One is obviously because we don't want to be able to kill it before it's actually appeared, and the other one is it gives us some rather unnecessary side effects as well when we actually do trigger the boss. So what we're going to do then is we're going to think about how we could alter this so that the boss isn't aware of anything going on until it's actually been triggered. So I'll press F8 to close that down. The first thing that jumps to mind is actually we just need a boolean really just to tell the boss whether it's been triggered or not, and if it hasn't then it's not going to take any damage, and if it has then it's going to start taking damage. That's the first thing we'll do. There's going to be a slight issue which we'll come across, which is a bit more tricky, but we can certainly implement that. So I'm going to select the boss then, so that's our boss scene, close down the output, and then go into the script view. At the top of the script that we've got written for the boss then, what we can do is drop ourselves in then a boolean that can deal with this. So I'm going to say has triggered is equal to false by default. Then what we can do inside the take damage then, much like we have with the if underscore invincible here, what we can also do is simply say that if has triggered is equal to false, then we aren't going to be taking any damage. Then scrolling further down the bottom here, what we want to do is make sure that when we've actually entered the trigger area, that's when we can say that we have triggered is equal to true, and therefore we can start actually taking damage. So if I do Control S to save and go back to the level base then and run the level, what we should find now is the boss is not able to take any damage. So I'm going to shoot. We're still going to see the messages saying that both areas have detected the bullet, so the bullet's detected hitting the boss and the other way around, but what you don't see in here is the notification that we're taking any kind of damage, which is what we want. If I now walk forward and actually trigger the boss and try and hit it, there we can see that it actually did take some damage here. We do still have a bit of a problem though. If I just close down the game and rerun the game, if I now shoot at the boss, you'll notice that the bullet still disappears. And that's because the bullet is still detecting that it's entered the hitbox, and also the hitbox is detecting the bullet as well. What makes the bullet actually disappear, if we go into the bullet base and into the code, is it has this on area entered, and if something with the appropriate mask has entered the collision area of the bullet, then the bullet queues free and disappears. If we select the actual player bullet then and go to the scene there, we can see that the layer setup indeed is to emit signals when something on the enemy hitbox layer actually collects with this area, and then it'll emit this signal and disappear. If we go back to the boss and then have a look at the hitbox, we can see that the boss has indeed this layer set up. So to prevent the bullet disappearing is actually a little bit more tricky. What we need to be able to do is somehow alter during the play of the game these layer and mask settings here. In other words, what we're going to need to do inside the boss and with the boss's hitbox is we're effectively going to have to set this layer like so to start with, and then when the boss has been triggered, what we then want to do is activate the layer 3 here. Now when it comes to the project settings, the way we set the layers up is inside the project and the menu there, and we've given all of our layers different names. We can see I've called this one enemy hitbox. When it comes to do it inside code, you've actually got to do it with the specific values for the layers. The other thing you may have noticed with the layers as well is they're actually binary bits. So the first value 0 here is a 1, then we've got 2, then we've got 4, then we've got 8 and so on. So if you wanted to set the collision layers programmatically, say for layer 3 and layer 1 here, you would actually use the value of 1 plus whatever's here, which is 4. That would then be 5. That's 1, 0 and then 1. In our case, we're only wanting to set this layer here. That's the third layer, but the third bit has a value of 4. Therefore, what we want to do once the boss actually has been triggered is we want to set the collision layer to be a value of 4. That's then the enemy hitbox, and then the bullet will start detecting this. The good news in terms of code is that's actually only one line of code. The first thing we have to do is deselect this collision layer with the hitbox selected so that we're no longer emitting or causing the bullet to emit a signal. It's not going to detect this. In fact, we can actually test this by going into the level base, running the game. What should happen now is when we fire a bullet at the start of the game, it should just fly past, and indeed it does. It just flies past the boss. It's not detecting the area anymore. And what we want to do then inside the boss.gd, so I'll go to the boss scene inside the boss.gd then, is actually just set this collision layer up. To do that, we need a reference to the hitbox area 2D. I already have a reference at the top of here. I think I added that in before pressing record when I was sort of playing about with things. So what you need to do is just control drag the hitbox into here. What we can do then is we can scroll down to the on trigger entered. And once it's triggered, what we can do then is we can set things up in here. So I'll say that we'll take our hitbox and then we want our collision layer. And then we can set that collision layer equal to 4. Don't confuse that with the 3 here. These are consecutively numbered 1, 2, 3 and 4. They're actually bits. The third bit is 4 here. Now in an ideal world, of course, maybe you might go into the game manager or something and set up here actually a constant for this. For now, just for a quick end to this section and this little fix, I'll leave it as a 4 there. So what should happen now is when we fire bullets before triggering the boss, they just fly past. And now when we trigger the boss, they should actually detect and disappear because they'll be set to emit a signal when this layer then has collided with their area. So let's test it then. That should be all we need to do. I'll go back to level base, run the game. And running the game then, let's just test this by firing a bullet. Okay, nothing's happening for sure here. And what we should be able to do then is trigger the boss and now hit the boss and the bullets disappear if I can. And indeed the bullet disappears and the boss is damaged. Excellent then, so that sorts out that little issue there of actually being able to kill the boss before it's actually triggered. Now we can only hit the boss once the boss has been triggered. Hello and welcome to this little bug fix video, or feature fix video, whichever way you'd like to look at it. A kind student has pointed something out that they didn't like, quite rightly, with the platform game, and that was that if we get hurt by, say, some spikes on the floor, like you can see on the screen here, if we stay still and the invincibility ends, then we don't get any new damage. I've got the level base open on the screen here, so that was our sort of play level. The player is instantiated here, and I've added some floor spikes in here as well, just so that we can take a look at the effect that the student was talking about. So if I run the game, and then walk up to the spikes, you can see that I get damaged, but if I stay still, and the invincibility ends, nothing happens. In fact, I can stay inside the area of the spikes and walk around, and I'm not being damaged, which is not really desired behavior. I have to go out and then back in because that then triggers this on area entered to be damaged. And that's what we want to fix in this video. So I'll press F8 to close that. There are a load of ways actually you could go about fixing this, and I've gone for what I think is the simplest way to do this. If we go into script view and actually go into the help, I've already got the area 2D selected here. If I double click on the area 2D, you might notice that it has a function called get overlapping areas. What that does is return a list of all the areas that are overlapping our collision shape. Note that we're separating bodies and areas here, so be careful with that. If later on you want to adapt this code and you also want to deal with bodies as well, make sure to use the get overlapping bodies. In our case, what we're going to do is look at the floor spikes, which are in area 2D. Therefore, we want to understand if we have any areas actually overlapping our collision shape. And then what we can do is check what that area is and then see if we need to take damage again. Now, the way we're going to check what that area is quite simple. What we're going to do is create ourselves a group. So with the floor spike scene selected at the top here, on the right-hand side with the inspector, I'll go to node, select the groups and add a group called dangers. Now all we need to do is ask whether any area we're overlapping is in the dangers group, and if it is, then apply some damage again. So I'll Control S to save the floor spikes, go back to the player, Now what we need is a reference to the actual hitbox. So I'm going to control drag the hitbox into here. So we've got our hitbox, and then scroll all the way down to the bottom of the code somewhere, if I can remember. Yep, okay. So we've got the on hitbox area entered. That's a signal here. So we'll do this below the apply hit. I'm going to write a new function inside here. This function is going to be called retake damage. It's the best name I could think of at the time, so I'll stick with that one. What we're going to do is we're going to iterate through all of the overlapping areas for our hitbox. We'll say for area in hitbox.get overlapping areas. Then what we want to know is we want to know if that area is in dangers. So if it's in dangers, then what we need to do is we need to apply a hit. Now when we've done this, we need to be a little bit careful here. So what we're actually going to do is straight away return from this loop, because if you've set things up, say, very complicated with overlapping dangers, we don't want to be applying a hit multiple times, if you see what I mean. So we'll immediately return from here. In fact, now I see that code here, what I'm actually going to do is I'm going to say break like so. Finally, then what we want to do once we're outside the loop is we just simply want to return. So we'll either have applied a hit inside that, or we'll have just returned out of this directly. What we need to do then is we need to invoke this retake damage at the right place. So if we scroll down to the on invincible timer timeout, it's here when we've stopped playing the invincible animation that we actually need to see if we need to retake our damage or not. So that means check whether we're still inside something that's causing us damage, and if so, then we're going to take a hit again. That should be all we need to do to fix this particular issue. So I'm going to go back to level base and 2D view just because it's nicer, and let's see if things work a little bit better. So I'm going to walk up to the spikes, get hit, and I'll wait for the invincibility to end, and hopefully, yep, we're taking some damage now each time the invincibility ends, which makes the game a little bit better, and the student who pointed that out was obviously quite right. Welcome back to this Godot 2D game development course. In this section, we're going to dive into the creation of a timeless puzzle game, and that's Sokoban. You might also have known this as Box World many years ago. This section is all about mastering tile maps, and there's a bit of a twist with this. We're going to build our tile maps entirely from code. The primary goal for this section is to understand how to dynamically create levels by reading details from a file. This practice is common in many games, and learning it will significantly boost your game development skills. We'll go through the process of constructing the game levels, the tile maps, and also the different elements of Sokoban completely through code. This is going to mean that we're going to need to dive even deeper into GD script, which also then enhances your knowledge and proficiency. What we're also going to do to make the game a little bit more competitive and engaging is introduce a feature to save scores to disk. This allows us to persist the scores then between plays. Sokoban is a game that I really personally love, and I think it's a testament to the fact that a simple concept can become a really engaging game, much like the Flappy game as well. So with that being said, let's start diving into the code and build ourselves Sokoban. Okay then, so familiar start hopefully now for you. What we're going to do is create a new project. You can see that I've set myself up here with a new project called Sokoban. That's going in the same folder as all of the other projects. All of the other options, mobile and no version control selected. I'm going to do create and edit. Creating that should bring you into the familiar view. Let's go straight into 2D view. Let's go to project settings and to window here. And we're going to have 1024 by 768. Then what we'll do is scroll down a bit and we'll do canvas items and keep the aspect as well, so we're stretching everything okay. The other thing we're going to do is go to textures in the rendering section and set this to nearest, because we're going to be using pixel art in this one, so we don't want any blurring or anything like that. And then we can hit close and Control S to save. As ever attached to this video, you should find a sokoban.zip which has the assets inside. I've extracted the zip here. I'm going to grab hold of both of these and drop them into the file system. As I do that, it crashes the IDE, as you've seen, so I'm going to restart the project. And after a quick edit, we're back with the project loaded. So it did crash that time. I've managed to get away with it, I think, for the last 2 or 3 games at least, but this one, it crashed. So down inside the file system then, I'm going to get the icon.svg and just delete that. Then go to project settings, and in the run here, in the config, we can select our icon. So I'll select the icon.png, close and do Control and S to save. Next, let's just make a sort of default scene here. So we'll make a new 2D scene. Let's change this to level. We'll do Control and S to save, and as ever, create a new folder in the root of the project, call that level and hit save. So the project's now set up. Next video, we can start looking at how we're going to build this. Before we start coding the game, it's worth taking a moment just to look at how it's going to work. In terms of graphics and actual sort of visual setup, it's by far the easiest of the entire course. There is a reason the game is at this point in the course, however, and that's because we're going to be doing things behind the scenes a little bit more complicated than we've done until now. The main screen will look something like this. We'll be able to select from level 1 to level 30 to play, and you'll notice that the tiles we've got here to select the levels, a couple of them have got these green checkboxes. What the program is going to do is actually going to save which levels you've completed until now, so you'll get a little green check if that level has been finished. It's also going to save the best number of moves you took to complete that level as well, and those will be persisted like we did for the high score in the platformer. The difference here is it's actually not going to persist any data for a level if we haven't completed that level at all. That just simply won't be persisted in the file. And like we did with memory, we'll be building this interface up from code, and we're actually going to have a big JSON file, so a dictionary full of all the details of all the levels that we're allowed to play. Now, the levels we're playing are actually coming directly from the original Box World game, which I think is the most famous of all of the Sokoban games, and it's really, really fun to play. In terms of what we're going to learn, though, there is a little bit to it. So on the top left-hand side, we have a very, very simple UI here, just with the levels, the number of moves taken, and the best score, if we have a best score or not. We're going to navigate simply using the keyboard, so we'll do Q to quit and R to reload the level if we want to restart and try again. The actual level itself, a little bit more interesting here. So these are clearly tiles that we have set up here. We're actually going to build all of these levels from inside the code. We're not actually going to place any tiles by hand at all. Not just that, but we're actually going to have different levels to the tiles. So we've got some floor, so we'll lay out some floor. We have some walls, so we'll lay out those on a separate layer. Then we've got boxes, they'll be on their own layer. We've got the targets that will also be on their own layer. All of these will be built up from this JSON data that we're going to use as the basis for all of our levels. Now, building a tile map from code is quite a challenge compared with doing it visually, and we're not actually going to stop there, because also when we play the game, we're going to be moving the player around and we're going to be pushing boxes. That means when we push a box, we need to remove the tile where the box is and replace it on the tile in the direction it's being pushed in. That means also inside the code, we're going to be removing and replacing tiles as well. So whilst the game looks very, very straightforward in terms of its graphics, there's actually going to be quite a bit of code to deal with actually playing the level. And that's why I've got the game on this course, because I thought it would be a good idea to show you how to manipulate tiles from code as well as the interface. Okay then, so back in the interface, let's start building up the game. The first thing we're going to start with is actually making the tile map that we're then going to use to create our levels from code. So what we can do then inside the level is add in a new node, and that's a tile map, which you're familiar with hopefully from the platformer. On the right hand side then we need to make ourselves a new tile set, so we'll make a new tile set. Inside this we want the tile size to be 32. We've got slightly, or twice as bigger tiles as we had for the platformer. In this game, the way we're going to build things is in layers of tiles. We're going to place the tiles on top of each other, and then we can move the tiles we need to around their different layers without affecting tiles on other layers. To set up some layers is really straightforward. On the right hand side, if I just minimize the tile set there, you can see this layers option. So we're going to make a new layer and we'll call this one floor. It's important to note what spelling you use for these layers, because we're going to be using these names to reference the layers inside the code. Then we can make another layer with add element and we'll call this walls. Then we'll add another layer and we'll call this one targets. And then finally we can add a last layer and we'll call this one boxes. Now what we can do is we can make some more room for me anywhere here. I'm going to scroll back, select the tile set again, and we can see with the tile set window automatically set down the bottom here that we don't have any tiles. So if we go into the assets, there aren't many assets for this game, so I haven't even put them actually in their own folder. I've just left them all inside here. We can see one of them should be called a spritesheet.png. So let's drag and drop that one into the little window here. Godot automatically says, would you like to create the tiles? The answer is yes, absolutely. And bingo, voila, it's created the tiles for us. The next thing we're going to do is we're going to give our tile atlas here actually a name. So we'll call this one level_tiles. So we know what this is, and do Control and S to save. What's going to become really important for us is actually when we hover over here. You can see that the source here is 0. So that's this ID of this atlas up here. And you can see the coordinates of this box is 0 by 0. And this box is the box when we're on top of a target. This is a box that's not on a target. It's at coordinate 1 by 0. This is a wall, which is at 2 by 0. The floor starts at 3 by 0 and goes up to 8 by 0. And finally, the target tile is on 9 by 0. We're going to be using these coordinates from code to be able to specify which tile we want to draw at a particular position on the map. Now we'll be drawing the levels by code, but for now what I want to do is just draw something out by hand so you can see how the layers are going to work. So what we'll do then is we'll select the tile map down the bottom here so we can draw something, and then what we can do is we can select a floor tile. We can select any floor tile. Later on we're actually going to pick a random one from the ones available from the code. I'm just going to use the same tile now as a demonstration. Important thing here is to have the floor layer selected. So what we can do then is just very quickly just draw something out. We don't need to be too worried about what this is or how it looks. It's simply just to show you how things are going to look. So these are drawn then on the floor layer. On the right hand side here, you can see that we've got this highlight selected tile map layer, and we've also got the grid visible here as well. This tile map layer is going to be important now because we're going to be using different layers. Now that we've got some floor drawn on the map, what we're going to do is we're going to then draw some walls. But instead of drawing those walls on the floor layer, what we're going to do is we're going to select the walls layer. And now you can see that it's made the floor tiles almost disappear. That's because we've got this highlight selected tile map layer. So we're highlighting the current layer that we're drawing on and making the rest of it dark, so it's clear to see what we're doing. If I deselect that, you can see that the floor comes back. So let's reselect it. Now let's just draw some walls. Again, don't worry about what you're drawing as a level. We're going to create them from code. This is just for a demo. So now we have some walls, and those are tiles that are on top of the floor tiles. The floor tiles still exist. If I uncheck this highlight layer here, you can see what the map is actually going to look like. It's really important to understand that the layers are completely separate. So if I go and delete something from this walls layer here, let's say, so I've got the walls layer selected, I'll get the rubber here and just delete this wall here. You can see that we've still got the floor underneath here. So we've actually got two tiles layered on top of each other there. This is going to be important to understand later on in the code because we're going to move the boxes around the boxes layer, and obviously the floor on the walls are going to stay in place. What we can then do is we can move to the targets layer, select the target tile, and then unselect the eraser, otherwise we'll have problems, and then we can put maybe a couple of targets in as well. Finally then we can get the boxes layer as well, and we'll have two types of boxes. We'll have either a normal box just placed like this, or a box that's actually on a target. When this happens, we're going to switch out the box tile for the green tile because that's then placed on a target. And that's pretty much all there is to it actually. I'll just uncheck this so we can see all of the tiles here. You simply create layers and then put the tiles on the layers that you want, and then later on, as you'll see in the code, we can start manipulating the tiles on the specific layer that we want to manipulate. Now we have a little bit of a layer sketched out. What we can do is add the player to the map as well. Okay then, so we have a tile map. We need a player to sit on our tile map. So let's make ourselves a new scene. And this scene is going to be really, really simple actually. So we're going to make an animated sprite 2D. We'll call this player. And believe it or not, that's all we need. We're not even going to need a script for this one. On the right-hand side animation, we can make some new sprite frames. And then down the bottom, we can select our sprite frames. Let's go into assets, and there's the player idle. In the window here, if I zoom in a bit, you can see we've got 4 wonderful sprites. So let's do vertical, we want 1, horizontal 4, select and clear frames, and then we can add 4 frames. I'll change the name of this to idle animation just so we know what it is. It'll always be on this animation. We want this to be looping. We want it to be auto playing, and I'll put the speed at about 8 FPS here as well and do Control and S to save. Let's go up 1 level there, and then we can make ourselves a new folder called player and hit save. So let's have a look at our player here. Isn't idling at the moment, but the pixel art is crisp. Let's now go into the level and see if we can actually bring in a player. So selecting the root node, let's instantiate our player. And I'm wondering why the animation isn't playing, but we'll see what happens when we actually play. So let's drop the player somewhere in the middle of here like this and do Control and S to save. What I'm going to do now is hit F6 and just run the scene and see what it looks like. When we run that, we can see that the player is there on the map and idling. Things are a little bit small though, so let's go about fixing that. Let's select the root node of level, and let's now add ourselves a camera 2D to this. On the right hand side, I'm going to set the camera zoom to 1.2 just to zoom things in a little bit. Let's zoom out and see where the camera is actually looking. What we can do now temporarily is move the camera actually onto the middle of our level like this. This will all be done from code later on, so this is just temporary. So let's put it there and press F6 to run again and see what the scene looks like now. Okay, that looks a little bit better. Let's expand this out as well, just to see if the sizing is okay. Yep, that looks about right, I think. We can always zoom it in a little bit later on if we need to. So I'll press F8 to close that. So that's actually it, I think, pretty much for the visuals in the level, because we're going to be building everything out from code. To be able to do that, we actually need to be able to load up some level data. So we'll start looking at the level data in the next video. Before we start jumping into coding up the levels, I want to explain a little bit about the data that we're actually going to use for the levels. You're surely going to receive a resource, and that resource will be all of the level data for the entire game. That's going to be in JSON format. That's something we came across a little bit in the previous section. I mentioned then that JSON is essentially like a dictionary in terms of GD script or Python or something like that, where you have keys and values. The thing about JSON is it's very specific for the format. So the keys have the double speech marks, the values for numbers don't, anything else does. And it's saved basically as plain text in files, or it's sent over the internet or something as an API as plain text. Once received, most programming languages can then convert that plain text into an internal object or dictionary, which is what GDScript is doing. The level data that we have on the left-hand side here is how it actually is inside the file. It's all basically one long line to keep the space down to a minimum. On the right-hand side, I've used this JSONformatter.org to actually format it to be readable for a human. So what we basically have is one huge dictionary or object, and then we have a key in that at the root for each level. When we select a level, we get another object that has two keys, tiles and the player start. The key tiles contains another object, and that has then floor, walls, targets, target boxes and boxes. And if we have a look at, say, targets here, you'll see that that is a list of yet another object that has a key coordinate, and that has then an X and a Y, which tells us the coordinate of that particular target for the level. All of these keys, floor, walls, targets, target boxes and boxes, contain the coordinates for the tiles that we're going to need to be able to draw the level. Target box is a little bit of a special one. That's telling us where we've got a box already on a target, so we can set up the green box instead of the brown box. You can see in level 1 here, that's empty. There's nothing already on the target. The player start is also a coordinate, which says the coordinate on the tile map for placing the player to start the level. Now, I've mentioned a couple of times coordinates there. That's an important thing to understand with regard to the tile maps. So a tile map has coordinates for the tiles. It's not coordinates in pixels, it's coordinates for the tiles. It starts top left at 0, 0, and then just as with the pixels, the Y increases going downwards and the X increases going to the right. So what we can imagine here then is that the first wall tile here is at the coordinate 3 in the X direction and then 1 down in the Y direction. This wall here would be at 1 in the X direction and then actually tile number 4 in the Y direction. So when we're loading up this JSON data to create our level, we'll be using these coordinates to know specifically where to place the tiles. If you're wondering where I got this data from, I actually wrote a Python script and just scraped it from a website that already had the levels. So I'm sure you're getting the idea of what we're going to do. We're going to load up the JSON data into an internal dictionary when the program starts, and then each time a level is selected, what we can do is we can then start placing the tiles out according to the coordinates inside that data. Okay, now that we know we're going to have some data that we can load, we need to actually put this data inside the project. So I'm going to right-click on resources and do a new and folder and call this data. You should find attached to this project a file called leverdata.json. Please grab hold of that file and drag and drop it into the data folder. Now sometimes when I do this, it doesn't go straight in there, it'll go in the root of the folder. If it does, please make sure you've dragged and dropped it inside the data folder so you've got this leverdata.json here. To load this data, we'll use a singleton, so let's right click, go new and folder, and a new folder called singletons. Inside here, right click, new script, and I'll call this game data. What we can do is go to project, project settings, auto load. Let's load up inside singletons our game data, click add, and there we are. So close and control S to save. Inside this singleton then we can set up the code to load up the game data. So I'll delete the process, we don't need it. What we are going to need is a level data path. So we'll do const level data path. That needs to be set equal to our file, so I think we can just drag and drop that there, and that should give us the string. Excellent. So don't forget later we can add another constant called tile_size here. That'll be an integer and a value of 32. We're going to store our level data, which we know already is a dictionary or an object. So we'll have a variable called level_data, and that'll be of dictionary type, and that can be set equal to an empty object straight away. What we need to do then is load this data. So we'll do func load level data. Here then we can get our file by saying var and file. I think we've done this in the previous section, so we need the file access singleton. And then what we can do is do open, and then we want our level data path, and we want file access.read. So that gets us our file. Let me make some more space there. Now that we have that, we can just use the JSON library to load up our level data. So we'll say that's equal to JSON dot, and we want parse string file dot and get us text. We can do Control and S to save. We need to invoke this function, and so we'll put it there inside the ready. Control and S to save, and also below here, let's just do a parse as well and put a breakpoint there. Okay, let's run this actually, even though there's nothing going on inside the level scene, just to check that we're loading up the data. So I'll do F6 to run the level scene. The level scene was selected at the top here, and we hit our breakpoint. Let's have a look at the level data. So we see that it has loaded. We've got 40 levels, and we've got the key 1, 2, 3, 4, 5, 6, and so on. There's one really important thing to note here about the keys. The keys are not numbers, they're strings here. You can see these little speech marks. So we can't use a level number to access this. We need a string. That's important to remember later on. So I'm going to stop that running. Let's, minimize that window for a start. What we can also do is write another function called getDataForLevel. Here we're going to take in a level number, which will be of type string. And the return here will be a dictionary. Inside here then we simply need to return, and we want our level data, and then we want the level number. Now one important thing to note here is we are assuming that this level number does exist inside here. I'm going to assume this because it's very difficult for it not to exist inside here. Therefore I'm going to leave this like this. You might want to put some protection in there if you want to. I don't. To finish off this video, I'd like to just test out this getDataForLevel. So what we can do is make a new script on the level scene. It is selected for me at the top here, top left there. So with the root node selected, let's add a new script, accept all of the defaults. Inside the ready here, what we can do is just make var, and we'll call it D for now, and then we can get hold of our game data singleton, and then we want something like getDataForLevel, was it? Yep, getDataForLevel, and we'll send in the string. Let's do 10 here, just for an example, and then beneath there we'll do parse and Control and S to save. I'll put a breakpoint next to the parse, and now what we can do then is we can run this with F6. So we've stopped at hopefully our first breakpoint here. Yes, we have with the level data. More interested now in the next breakpoint to see if we've got the level data. And we've stopped here. Let's check out D. And D should have something in it. I'm not sure what level 10 is, but we've got some tiles clearly. We've got the floor, the walls, the target boxes and boxes. And then we've also got the player start, which is on 5 and 7. What we can actually do here is stop. Let's change the level to 12 here. And then I'm going to do F6 and run this again, just to see if it's different to 5 and 7. So second breakpoint required. Let's have a look at player start. That's now 9 and 4. Excellent, good. So stop there. Let's remove the breakpoints as well, because we don't need those anymore. Good. So we've written some code to load in our level data. It's now stored in a dictionary, and we're able to get the data also for a specific level that we actually want to load inside the game. Now we're ready to start the more complicated part, and that's actually building up the tile map from the code. Okay then, so we're going to begin the process now of setting up the level from code. There are a couple of really important things we need to look at before we do that though. Let's go to the tile map and actually open up the tileset window here. In the tileset window, we can see that with the setup clicked here, so the level tile selected in the setup, that we have this ID 0. We're going to need this ID to tell Godot which atlas we want to use on our tile map to actually get our tiles that we want to set. Once it knows that, it's also going to need the coordinate of the particular tile as well. And if I hover over one of these, you can see this one is 2 by 0 and so on. So it's going to need the source ID and also the coordinate of the cell inside here. The other thing it's going to need to know is what layer we want to put that particular tile on. On the right hand side, we've got the floor, the walls, the targets, boxes, layers. They will be numbered in the order that they are on the screen here. That means the floor layer is layer 0, walls is layer 1 and so on. We're going to be setting the cells using a setCell function, which is part of the tilemap class. Here's the function definition from the documentation, and I've highlighted the important arguments that we're going to use and where the information is coming from. So when we want to set a particular cell, let's say we want to set a box somewhere inside the tile map, first thing we have to do is give it the layer number as an integer. Now, unfortunately, as of filming anyway, with the tile map class, you cannot get the layer integer by giving the layer name. That would be very convenient. Unfortunately, we can't do that. You can do the other way around. You can send in an integer and get the name back, but we can't do the reverse. So we're going to, in the code, set up some constants that have these floor, walls, targets, etc. set up and hard coded as 0, 1, 2, and 3, etc. So when you set the cell, you have to send in the layer as an integer. Then you send in your coordinates for the tile. So we looked a little bit at the coordinates here with the 0, 1, 0, etc. It's not pixels, it's tile coordinates. And those coordinates are a vector 2i that you can see here. That is a vector 2 of integers, not floats. Then we have the source ID. So that is which atlas source are we coming from. In my case here, the ID is 0. Yours might be different, but you need to make note of this number. Then finally, we have the atlas coordinates. Again, it's a vector 2i. This is an integer vector 2, not a float vector 2. And this is this coordinate that comes from these tiles here. So we need these 4 pieces of information inside here, the layer, the coordinates, the source ID, and the atlas coordinates, to be able to set a particular tile on a particular layer inside the tile map. So back into the interface then, we can start coding all of this up. The first thing we need to do is grab some references, and we can grab one actually to the camera and player and the tile map all at the same time with a control and drag. We'll be needing the player and the camera later on. We won't be needing them right now. And what we're going to do is put some constants in here. Now I've provided a text file with this video that actually has the constants already prepared, so you can just paste them in. So I'm going to grab what's in that text file and just paste it in here. So you should have a set of constants that look something like this. The first set of constants here are these layer numbers that we need. So the floor is 0, wall is 1, target 2, and box is 3. Make sure yours are set up like that inside the tile map. It's really, really important. I'll just say it once more to emphasize: floor, walls, targets, boxes. Next, we have the source ID, which for me was 0. Yours might be different. So back to the tile set, the atlas ID is 0 here. If yours is different, then please make sure your source ID is different to this one here. Now we have some layer keys. These are corresponding to the keys that we have inside our level data. If I flick over to the JSON, it's these keys here. What we then do is set up what I've called here a layer map. That's mapping the key that we have in our JSON data to the number of the layer that we want to put it on. So we have the floor key mapped to 0, the walls to 1, the targets to 2, and then the target boxes which come out of the JSON, they're going to be mapped to the box layer, as are the normal boxes as well, also on the box layer. So now that we have those constants in, we can start the process of writing the code to set everything up. So what we'll do then is we'll write a new function called setUpLevel. First thing we'll do inside here is get a hold of our tile map, and we'll clear it of anything that's on it. That's anything that we've drawn so far will be cleared from the code, so we don't need to go into the level and do that by hand. It's now been done for us. Now what we need to do is get hold of our data. So we'll get hold of our level data, and we'll set that equal to, and we can actually set now this hard-coded to level 12. We'll put that inside here. The reason we're not doing that inside the ready or anything is because when the game's actually finished and we select a level on the main screen, we're going to actually store in a singleton which level was selected, and then this setup level will grab hold of that and load it out of here. For now, hard-coded to 12. Once we've done that, we can get hold of the tiles. So we'll do var level and tiles is equal to level data.tiles. Just in case that's not clear, once more where that's coming from, if I go back to our JSON data, remember, it looks like this. We've selected a level. In our case, it was 12, but I'll leave this as 1 for now. So we've got an object like this. What we're grabbing is this object here under the key tiles, so that we should have an object with floor, walls, targets, target boxes, and boxes. What we can also do is get the player start as well. So we'll do player start, and that's equal to level data.playerStart. Once we have that, then we can loop through each of the keys that we're expecting to have that are inside our layer map. So these keys here, remember, are all of the keys that we have inside our JSON data. So what we'll do then is we'll say for layer name in layerMap.keys. So we are looping through these keys here. And for each of these keys, what we want to do is grab the list of tiles there, and then we want to add those to the correct layer. So what we'll do then is we'll do add layer tiles. Then we'll send in here our level tiles, which we've loaded up. We'll use the key of our layer name, and then we'll also send in our layer name. Now we haven't actually written the function add layer tiles yet, so we can do that then above here. So we'll do func and add layer tiles. So we're sending into here then our layer tiles, and we're also sending in our layer name, which is a string. For now, what we'll do is we'll just type pass here and do Control and S to save. And the reason for that is I want to check that this is working up to this stage, and we can see that we are getting the data we expect. To make this work, we do need to call setup level though from the ready, so we can delete what's there and do Control and S to save. So now hopefully everything's okay. We can press F6 to run this, and then I can immediately press F8 to close this because I need to set a breakpoint. Let's set a breakpoint here on add layer tiles, and then we'll also set a breakpoint then at, let's say, we'll set it here on the 4-layer name. So F6 again this time. Okay, now the debugger has stopped, but because I have the tile map selected on the left here, it's actually defaulted to the tile map window. So down the bottom here, I'm going to select the debugger, and that brings us into the debugger. So checking the level data, you can see that we've got some level data here. We've got dictionary of 5 keys with under tiles, which is the floor, walls, targets, and boxes with all the number of tiles there. You can see we've got 48 tiles for the floor, for example, and we've got 3 sort of boxes here on the coordinates. Let's have a look at 7 and 5, for example. We also have the player start here as well, which is on 9x4. Now, if we continue, what we should then get is the first layer, which is floor, layer name, that's good, and we've got 48 tiles. If we continue, we've got walls and 26, that's good. Then we would be adding 4 targets, then we'll be adding 1 box on a target, then we'll be adding 3 boxes not on target. That makes sense because then we've got a total of 4 boxes and 4 targets, and then going again, and that should be the end of that, and we've got the player sitting in the middle of nothing because we've cleared the tile map. So I do F8 to close. That seems to be working okay. What we need to do now is we need to write the functionality inside here to actually create these tiles and place them on the map. Okay, now that we've got the data in our setup level, or we're confident we're getting the tiles and the layer name, we need to start setting the tiles up. We're going to need to write 3 different functions here. The first one we're going to use to actually get the coordinate from the tile atlas. If I go back here, that's this atlas coord here. So where the first one here, this green box here is 0x0 and so on. So we'll write a new function called getAtlasCoord for layer name. And here we're going to take in a layer name. Note the return type vector2i, so it's an integer vector, not a float vector. Now what we need to do is match the layer name. So we can do match layer name. And then we're looking for, first of all, the layer key floor. Now the floor, if we go to our tile map and into the tile set here, the floor starts at 3x0 and ends at 8x0, and we want to get ourselves a random floor tile. So what we'll do then is we'll return, and we want to return a vector2i, and here we want to get a rand I range. I think we've got, yep, random integer range. We want to go from 3 to 8 and then by 0, and that'll get us then a random floor tile. Next then we've got the layer key, and we can do the walls here. In my atlas, that is at the coordinate 2x0. So I'm going to return here a vector2i, and that's going to be at 2x0. Now I'm going to do is be a little bit lazy here and just paste this down 3 more times for the other layers. So this one is going to be the layer key targets, and this is at 9x0 in my atlas. Make sure you've got the correct one for yours. Then we want layer key target boxes. That one is at 0x0 in my atlas. And then finally we've got layer key boxes, and that's at 1x0. If none of those match, which would be very strange, then let's just return vector2i.0. So that now gets us the tile atlas coordinate for a given layer. Now what we need to do is actually write a function that specifically adds a tile. That means we need to get the layer number. It means we need to get the coordinates as well for our tile, which are inside the actual data from the JSON. It means we need the source ID, which we have as a constant, and it means we need the atlas coordinate, and we've just written the function to do that. So we'll write new function add tile. That's going to take in a tile coordinate, and it's going to take in a layer name. Now you might be wondering why the tile coord is a dictionary here. This is the tile coordinate that comes from our JSON data. Inside our JSON data, the coordinate that we have here is actually an object with an X and a Y. So we're going to have to do tilecoord.x and tilecoord.y to actually get the correct values. So the first thing we need to do then is actually get the layer number. So we'll do var and layer number, and we can set that equal then to our layer map and then our layer name. Then what we want to do is get the actual coordinate for our tile. So we'll say var, and I'll say coord and underscore vec. So I know it's a vector. That's going to be this vector2i. And we can set that equal to then a vector2i. And here we want to take our tile coord and we want .x and our tile coord .y. Now we want the atlas vector as well. So we'll do var atlas vec. And this then is going to be the function that we've just written, the very long one. So get atlas coord for layer name, and we'll send in the layer name. Now we have all of the information to actually set a tile. So we'll call our tile map.set cell, and we'll send in then our layer number. Then the next argument on here says the coordinates, that's our coordinates. Then the next argument here says our source ID, we have that as a constant. And then finally what we have is the atlas coordinates. And Control+S to save. So we're now able to add a tile. Last but not least, what we need to do is iterate through our layer tiles and actually call add tile for each of the tiles that we have for our layer. So we'll do for tile coord in layer tiles. And then we can call our add tile. And then we want to send in our tile coord here and our layer name. Control+S to save. That should be, I say, all we need to do to actually set up the level for a given level that's been selected. So let's press F6 and see what happens. And I run that and straight away get an error with invalid. Oh, I know what I've done here. So let me just close down the debugger and stop that. I've made a really silly error there. Actually, I'll run that again so you can see the error. So it's saying invalid get index x on base dictionary, and that's here. So if we look at the dictionary we have as the tile coord, we can see it's actually the object with the key coord and then the x and the y. The reason that's given an error is because down here in the loop, I'm sending this tile coordinate in directly as this object. What I wanted to do was tile coord dot coord, and that would then send in the object with the x and the y. So let's stop that here and do dot coord and Control+S to save. That should fix the issue now. So let's try this again with F6. And there we go, we have the level set up. Now we're going to position the camera so the level's in the middle, and also obviously position the player later on, but the main thing is that we're able to build the level. That's pretty good. Let's press F8 to close that down and just find another level. Let's try something like 24 maybe. I'll do F6 to run this again. Let's see what we get. Good, and we get another level, so I'm pretty happy there actually that that's working. Let's just satisfy the curiosity by maybe trying one more. I'll try level, I don't know, 21. Try something like that, I don't know why. F6, let's see what 21 looks like. That's also loaded okay, so I'm pretty satisfied that's working. Now we need to work on actually positioning the player and the camera. Okay, then what I'd like to do now is place the player on their tile. If we go into the JSON data once more and just quickly take a look, the player will be placed on this player start here. So that's just a plain old X and Y, and that's the coordinate then for the actual tile map, not the coordinate in pixels. That means then to find the player's position, we're actually going to have to multiply the X and the Y by the size of the tile, which is 32, and then add those values onto the global position of the tile map. The tile map we actually have inside our level is positioned, we can see here if we select that and we get a transform hopefully on the right hand side, yep, we can see it's positioned at the moment at 0, 0, but we can actually position it to node 2D, we can position it wherever we want inside the level. Therefore, when we've got our tiles, when we're placing the player, we need to count the number of pixels we go along by multiplying 32 in this case by the tile coordinate, and then we need to also shift it according to the position of the tile map. That's because the tile map coordinates are counted from the root here. So we'll go 1, 2, 3, 4, 5 in the X and 1, 2, 3, 4 and so on in the Y direction. That sounds a little bit more complex than it probably is. Let's just dive into the code and code this up to set the player. So what we'll do then is we'll write ourselves a new function, and where should we put this one? I'll put this one actually above the get atlas coordinate for layer name. So inside here then we'll write a new function called place player on tile. And here we'll take immediately a tile coordinate, and that will be of a vector 2i. Now the player isn't a tile, remember, so we're setting the position in terms of pixels here. So we're going to say var, and I'll say new pos for new position. That's going to be a vector 2, and we'll set that equal to then a vector 2, open brackets. Now this is going to need a bit of space, so I'm actually going to go new line here so you can see things. We want to take the tile coordinate that we're sending in, .x, that's from the JSON data, remember, that's the player start that has the X and the Y keys. We want to multiply that then by our game data dot and our tile size. Then we want to set up our tile coord, and then we want the .y, and that's also multiplied by the game data dot tile size. And then we want to add on to that the tile map global position. What we can do then is we can take our player, which we've referenced at the top, and set the global position to be equal to this new position. Finally, last but not least, what we can do then is drop down into the function where we're setting everything up, and after we set up the tiles, what we can then do is we can then place the player on tile, and inside here then we want a vector to I, and then in here we want our player start.x and our player start.y. And we can do Control and S to save. What that should do now is that should place the player on the correct start. So let's do level 1 here, because I know more or less what this one looks like, and then we can do F6. We're going to have a little bit of a problem, I know this already, indeed. So the player is intersecting a load of different boxes. So let's press F8 to close this, and let's go and have a look at the player in the 2D view. The problem we have is that the pivot of the player, you can see here, is right in the middle of the head here, and it's this position here that's being set on the tile map. Now that's being set at the top left-hand point of every tile. Therefore, it needs to be offset to the right and also downwards. So I'm going to go to the offset on the right hand side here and offset to, I think I found that 18 in the X and 12 in the Y was about right for things to appear right. So I'll do Control and S to save, go back to level, let's do F6. We should see now that the player looks a little bit better on the map. And indeed the player is more or less, I think, in the middle of the start position tile there. Let's do F8 to close that, and let's try another level as well, just to make sure that everything looks okay. So we'll go back to, let's go back to our famous level 12 and press F6 to run this again. And there we go, we've got the player positioned nicely on the tiles in the start position. All we need to do now is position the camera so the level appears in the middle of the screen. Okay then, now that we've got the player positioned and the level being drawn, what we want to do is position the camera. So let's make a new function called move camera. The first thing we need to do is actually get the size of the level. Now that might be actually quite tricky to do, but luckily TileMap comes with a function called getUsedRect. That'll give you the rectangle in tile coordinates that's actually being used, so it won't include any blank tiles around the outside. So we'll do var tmr is equal to, and we can do tilemap dot, and I think it's called getUsedRect. Let's type pass there, do Control and S to save. Let's call the move camera directly after the place player on tile. And let's put a breakpoint there and just do F6 to run this so you can see what TMR is. So you can see that we've got the X and the Y, so 4x3. So that's the top left-hand corner of where our map starts. And we've got a width of 8 and a height of 7. If I just quickly go back to the slide we were looking at and try and draw a box here, effectively the rect is this box. Like this. So the top left hand side here will be that X and Y, which I think was 4x3 just now, and then it would tell us the width and the height in tile coordinates. This is really, really useful because it allows us to find then the center position of this in terms of pixels and put the camera directly over that. So I'm going to stop the game there and remove that breakpoint because we don't need it anymore. So what we can do then is we can get the tilemap start X, and that can be equal to the tilemap rect.position.x multiplied by the tile size. Now what we want is the tilemap endx. So I'm going to copy and paste this down here and change the start to an end. Now what we want is we want the TMR size x multiplied by the tile size plus the tilemap start x. I'm going to make a little bit of space here. That's better. Okay. Now we want to do something similar for the Y as well. So let's copy and paste that and actually make this a little bit more readable by putting some spaces in. That's good. So we'll have the start Y. That's equal to the TMR position Y multiplied by the tile size. And then we've got the end Y, which is the size.Y multiplied by the tile size plus the start in the Y direction. Now we've got the start X and the end X. What we need to do is calculate, of course, the mid positions. So I'm going to say var, and I'll call this midx is equal to, and then we're going to take the tilemap startx plus, and then we want to do the endx minus the start index divided by 2. We can then do the same thing for the y as well. So we'll do the mid y, and that's going to be the start y, and then the end y minus the start y divided by 2. Finally, we can grab hold of the camera 2D, and we can say that the position of that needs to be equal to, and then we want a vector to mid x and mid y. Control and S to save. What that should do is position the camera directly over the middle of the level. So let's press F6 and see if it does. And there we go. It seems to be in the middle of the level. Let's try another level. So I'll do F8 there, and let's try level 29 for fun and press F6. Try again. And there we go. Definitely now the level is in the middle of the screen. I'm going to try one more level just for luck. Let's try level 33, F6. And that's also in the middle of the screen, so I'm pretty happy that that's working. So that's great. We're actually now building our level entirely from code. We're positioning the camera and also positioning the player. What we need to work on now, of course, is the actual gameplay where we can walk around the map and start moving the boxes. Okay then, so now we've got the camera set, the player set and the level set, we need to start doing the logic for actually sort of running the game really. The first part of that is to actually process some input. So I'm going to go to project settings, input map, and add in right, left, up and down. Inside here then, I'm actually just going to use the WASD key. So another action I'm going to use is exit here, and for that I'm going to have the Q key, I think. And then another action here can be reload, so that's to reload the level, and I'll have that as the R key. Obviously you can use whatever keys you like. So close and Control and S to save. So inside the process here, what we want to do is some processing for the input. So we're going to do if input is action just pressed and right. Then what we want to do here is we want to first of all make sure that the flip H is false for the player here. So we'll put flip H is equal to false. Then what we want to do is I'm going to copy this actually, and we're going to go left, and here we want the player flip to be true. And then I'm going to go up and down here. And for now what we can do is we can just put pass inside here and Control and S to save. Now we're going to add a variable in here called moving and set that to false. That's going to be used as a little bit of protection to make sure that all the stuff we need to do, like moving tiles and that, is all done before we then process another move. What I'll do here is also set another one called total moves, so we can keep track of the total moves we've actually made, and we can set that equal to 0. So inside the process then, what we can do is we can say if moving is equal to true, then we'll return. Now we have that set up, what we can do is we can start writing a function actually to move the player. So what we'll do below the place player on tile, but above the get atlas, because this is all the kind of setup stuff. In fact, I'll put a comment here calling, let's call this level setup. So above here, what we're going to do then is the game logic. So game and logic. And we'll have a player move function. So we'll do func and player move. And here we want to take in a direction that we're trying to move in, and that's going to be a vector to I, because we're going to be moving the tiles, therefore we want the vector to I. So what direction are we going in? When we enter this, we're going to set our moving flag as equal to true. So we're going to do some logic in here, and we're not going to do anything with processing input until that's done. That means at the end of this function, then we can set moving is equal to false. Obviously, we're going to be doing some things in the middle here as well, otherwise it would be a little bit pointless. There's quite a lot of logic actually to moving the player around. So we need to be able to check whether the player can actually move to a tile. If that tile has a box, we need to check whether that box can also move in the same direction as the player. To start things off, what we need to do is get the tile coordinate that the player is actually on. To do that, what we're going to do is write ourselves a little function to get the player's tile. So we'll do func get player tile. And here what we want to do is get the offset in pixels that the player is from the origin of the tile map. So we'll say var and player offset, and that we can then set equal then to the player.global position minus the tile map global position. And now to get the actual tile coordinate, we need to divide that then by the tile size. So we'll return a vector to I, and then we'll take our player offset divided by the game data.tile size. That should get us the tile that the player is currently on. So I'll do Control and S to save. Inside player move then, we can do var player tile is equal to get player tile. Now we've done that, we can do var new tile is equal to the player tile plus direction. And what I'd like to do just for now actually is just print out the player tile. So I'll print out the player underscore tile and a colon and a comma and player tile. And what we can also do is print out the new tile, and we can also print out the direction as well, just so that we can verify in the console that everything's working as expected. I'm going to copy this player tile line actually, and down inside the setup somewhere we've got the player start. For now, let's just print the player start as well, so that we can use the arrow keys to check that we're actually generating the correct tiles here. So scrolling back up, so when we've got the player move invoked by pressing one of the arrow keys, we should then get ourselves a player tile, a new tile, and then print those to the screen, and moving should be set equal to false. Going down to the level, let's change the level to 1 from 33. And now we need to call the player move, of course. So let's go up to process. So inside process then, we can make ourselves a new var, and we'll call this move direction, and that can be equal to a vector to I.0. Then we'll set the move direction based then on what input we have. So this will be vector2i.right. And then I'm going to be lazy as ever here and paste this in here and here and here. And then we want down here, then we want up here, and then we want left here. Finally, at the end of the process here, we can call the player move function and we can send in then our move direction. So Control and S to save. Now, as the code is here, it's not quite right because we'll be calling this irrespective of whether we have any input to move or not. And that's a bit of a waste really. So what we'll do is we'll say that if the move direction is not equal to vector2i.0, then we'll call the player move. So what we can do now is press F6 to run this. And I can see that we've got the player start and we've got the X is 8 and the Y is 7. So it should be starting on 8 in the X and 7 in the Y, obviously. So I'm going to press W now and see if we actually get something. So we get the direction 0 minus 1, that's correct. That means we're going upwards. The current tile is 8, 7 and we want to go to 8, 6, that's correct. If we go to the right then, let's have a look. We've got the direction 1 and 0, that's correct. We want to go to 9, 7, that's correct. If we go down, we should be going to 8, 8, that's correct. And if we go to the left, we should be going to 7, 7, that's also correct. So we're definitely setting the correct target tile we want to move to. And I've also noticed if I do left and right, the player also flips appropriately as well, which is really good. Excellent, so let's press F8 to close that. That's the first step done in getting the player to move. Okay, now that we know where we want to go, we need to make the decision of can we go there? So the way that we're actually going to do this is we're going to ask a couple of logic questions. Let's imagine we want to go to the right hand side here of the player. What we're going to do is ask, is that cell that we want to go on inside the wall layer? To do that, we can make use of a really straightforward function on tile map, which is called getUsedCells. You call that, you send in the number of the layer you want to check, and you'll get back a list of all of the cell coordinates that are occupied on that layer. So if we want to move to the right, we can say, is that cell coordinate inside the list of wall layer used cells? If it is, then it's a wall and we can't move there. The logic obviously doesn't stop there though. What we've also got to do is ask, is there a box in the cell next to us? Let's imagine we're in this one here and we want to go up. If there is a box, we then need to check if that cell after the box is empty. If it is, then we know that we can make the move, and we need also to keep track of the fact that we saw a box because we'll need to move the box as well. Dropping back into the code then, let's write ourselves some functions to set this up. So we'll make one called cell_is_wall. This will be the first of sort of 3 cell_is functions. That'll take a cell that's going to be a vector2i and it's going to return a boolean. Here what we can return then is if our cell is in, and then we want the tile map getUsedCells and we want the wall layer. We can then copy this down and paste it and do cell_is_box as well because we'll be needing that. So we'll say cell_is_box and we'll put here the box layer. And then I'm going to copy and paste that down again and also make 2 spaces of line here. There we go. And this one can be cell_is_empty. Here we're going to return cell_is_wall cell is equal to false. And we also want to say that cell_is_box cell is equal to false. Next we can write another function which we're going to need, and we can call this one box can move. This is actually going to take in a couple of vector2s. So one of them will be the box tile, so box_tile. So this will be a vector2i. And then we also want the direction we're moving in, which is also going to be a vector2i. First thing we do is get the tile we want to move to. So I'll copy and paste that code there to be lazy. So that will be new tile is the box tile plus direction. And then we can return from here if the cell is empty or not. So cell is empty and the new tile. Now we have all the logic functions actually written to be able to do all the moving around the tile map that we need to do. What we can do then is go down into player move. We need a new variable asking can we actually move, and we'll set that to true to start with. Then we're going to have a box scene. So we'll say var box_scene and set that equal to false. We need to keep track of whether we saw a box trying to move because we'll need to move the box as well if we did. So we can ask if cell_is_wall new tile is equal to true, then can move is equal to false. Otherwise we can say that if the cell_is_box new tile, then we know we've seen a box, so we can say that our box scene is equal to true. Now what we can do is we can set that their can move is equal to whether the box can move or not. So we can say box can move and our new tile. Control and S to save. Now that we've got that logic done here, although it doesn't seem to like that at all. Oh, goodness me, I need to send the direction in here as well, don't I? Okay. So now we know whether we can move or not. What we can do is we can now ask some logic. So if the can move is equal to true, then what we'll do just for now to make sure this appears to be working is we'll print, and let's print can move. What we can also do is drop a print statement in here and make sure that we've got the box scene as well. And what we can also do is drop here and we can say wall scene. Control and S to save. Before running this, I'll just clear this space up here as well. Control and S. Right, let's see if our logic's then working. So let's do F6 to run this. So I'll go up one cell and it says can move in the output and there's nothing else. Now if I go down, it should say a box has been seen and we can move. That's correct. If I go left, it should say box seen and can move. And if I go right, it should say wall seen and we can't move. Good, that seems to be the logic working. So I'll press F8 to close that down. Okay, so the decision logic seems to be working. We haven't fully tested it in the sense that we haven't tested if a blocked box can move or not, if it's blocked by another box or a wall, but we'll soon see if there's a problem with the logic here when we actually start moving things around the game. And that's a good segue into the next video where we're going to start doing exactly that. Okay then, so now we're making a decision to move, we can finally actually move around. What we need to do is we need to write some code that actually moves a box tile. So let's scroll up a bit and we'll put this right at the top of the game logic here. So we'll do a function called moveBox. We'll send in the first parameter as the tile the box is on, so that's the box tile, that can be a vector2i. And we also want the direction as well, which is a vector2i. What we want to do first of all is we want to clear where the box is now from the tile map on the box layer. So we're going to grab hold of the tile map and we can call an erase cell function. We have to send in the layer, which will be the box layer, and we have to send in the box tile, which will be the tile that we actually want to remove. So that will now delete our box. Then we want to get ourselves where we're actually going to, so that's the destination. Let's do this at the top of the function because I usually prefer variables there. So I'll say dest is equal to, and then we want the box tile plus the direction. Now we want to place the box. We have to be a little bit careful here because if we go back to the tile map, you might remember that we have the green box if it's on a target and the brown box if it's not on a target. So we need to check first whether we're actually on the target layer or not. So what we can do is we can say if and then dest in, and then we want tile map get use cells target layer. And I'll type pass. Here we want to set a cell, but it needs to be the layer key target boxes. So what we'll do is we'll say tile map, and we've done this before. So we want the set cell, and then we want to go on the box layer here. We want to set the destination as where we're actually going in terms of a coordinate. We want the source ID, which is at the top. I'm going to go on a new line here just to make sure you can see everything. And then we want this get atlas coord for layer name, and the layer we're looking for is the layer key and the target boxes to layer target box. That sets us then a target box. Otherwise, what we want to do is simply set a normal box. So I'll type else, grab hold of this line here, paste it down to here, and what we want here then is layer key boxes. Control and S to save. That function should move a box for us. What remains now is down inside the player logic is just to move the player and move the box. So what we'll do then down here is, first of all, we can increment the total moves if we have that defined at the top. We do. So back down inside the player here, we can move. We're going to move. So we're going to increment the total moves. That can be plus equals 1. Then what we want to do is we want to say that if the box was seen, so if a box was seen, then we're going to move our box. So we're going to move our box from the tile that the box was on. That's then the new tile, and that's going then in the direction. Finally, what we want to do then is we want to place the player on a new tile, and that new tile then is going to be simply the new tile, and we can do Control and S to save, and that should be all we need to do actually to have ourselves moving around the level. And we'll also find out then whether the logic is incorrect for stuck boxes or not. So let's press F6 to actually run this, and I'm going to move up, and it does, and down, and it does. And can I move down and move a box? And it does, and it even changes color onto the target. That's great. So let's try moving that one to here. It does. That one to here. It does. That one to here. It does. That one to here. And can I move the box anymore? No, I can't. That's brilliant. So I'm not able to move those boxes or have anything actually move where it shouldn't be moving. In fact, I can't move anywhere around the level at all. Excellent. Let's just close that down with F8 and just drop down and find another level here. I'll do 16 at random and just do F6 and find a slightly more complicated one just to check the movement here. So if I keep going up, does the box move? No, the box is No, the boxes are definitely unable to move. That's pretty good. I'm not able to get through there. Good. That looks like the movement actually is up and working really, really well. That's good news. I can't get around there. I don't seem to be able to break it. I'm trying to break it. It's not breaking. That's really, really good news. So that's actually nearly all the game logic written. We've only got one more piece of logic to check, and that's to check whether the number of target boxes we've got equals the number of targets or not. And that tells us then that the game is over. Okay, then what we need to do now is write ourselves a function that checks whether the game is over or not. Before doing that, I'm going to remove these print statements from here. That's going to clean things up a bit. I'm fairly confident after the last video that most of that is working okay. Have we got anything else spurious up here? No. Good. So what we can do then is a check game state. We'll do this above the move box here in the game logic. So I'll do func check game state. Now eventually inside here what we're going to do is we're going to emit a signal if the game is actually over. For now what we'll do is just print to the console. So we'll do for t in tile map get use cells target layer. And now what we need to do is check whether that's actually on the box layer or not. So we can just do if cell is box and then t is equal to false, then we just want to return. Because what we want is every one of our targets to be on the box layer as well, and then we know we've covered all the targets. Otherwise what we can do here is we can just print and game over. Control and S to save. We can then take this check game state and go all the way down into the player move down here. And what we'll do then is we'll check the game state once we've placed the player on the new tile. Control S to save, and let's press, I won't press F6 actually to run this. Let's go back to level 1, otherwise you'll suffer. So change that to level 1. Let's press F6 and see now if we're able to check the game state. So I don't see game over at the bottom. That's good. Still don't. Hopefully do now. And game over. So the check game state also seems to be working, and you can see as I move it's still insisting the game is over, which it is. Let's press F8, go to level 2 and just do another level just to check. I know I can complete this one without messing it up in front of you, I guess, anyway. Oh wowzers. Okay, I might speed this up for you actually. So let's just try getting the boxes in here. That's the first one done. There's no game over. Okay, my guess is you've seen a little bit of an edit there, but now final one should say game over, and it does. So that's more or less all of the game logic complete now. What we need to do now is start thinking about setting up the main scene with all of those levels on it, and then we can start hooking up the moves and the scores and things like that. Okay then, so now that we're done with the sort of logic of the game, we've got to start thinking about the main screen. That's the screen that you can see on the slide here. And what we're going to start with is creating these buttons to be able to select a level. So let's go into 2D view. Let's make a new scene. And this is going to be another type of node, and we're going to use a 9-patch rect for this one. Let's change the name to level button. We've already seen, I think in the course, a 9-patch rect. This is the one that allows us to basically keep the edges of whatever texture we're using to stay the same proportion with each other so you don't stretch corners and things like that. We need a texture, so I'm going to go into assets. In assets then we've got this blue panel, so I'll drag and drop that onto the level button. On the right hand side then, let's set the patch margin to 10 pixels all around. And that should keep then the corners nice and rounded for us. Now I'm really zoomed in here, so I'm going to zoom out. That's a little bit better. It's still 188%, but it's not as bad as it was. I'd like to go to the layout and then set a custom minimum size here of 64 by 64 pixels. Then further down in the container sizing here, we're also going to set the horizontal to expand and the vertical to expand as well, and do Control and S to save. I'm going to create a new folder in the root of the project called level button, and then save the scene and Control and S to save again. Next, we're going to need a label for our rectangle. So I'm going to, with level button selected here, add a new node. That'll be a label, and we can call that the level label. This label then is going to anchor itself to the full size of its parent, which is the 9-patch rect. And then for the text here as a placeholder, I'll put 99 so we can see where everything is. We need the horizontal in the center and the vertical in the center as well. Then we should probably make ourselves some label settings as well, because that's not looking very good. So some new label settings, do font size 32 here, and then we'll also load ourselves one of the fonts as well. This won't surprise you, same fonts as always. I'm not going to take Luckiest Guy, I'm going to take the other one this time. So that's looking a little bit better. Maybe we can add shadow or outline, can't decide. Add a little bit of shadow on here, I guess. So we'll do a bit of sort of darker shadow, and then maybe we can do a couple of pixels of that, can we? Can't really see anything there. Let's go back here. Why is that? Oh, because the alpha's right down. Let's see. Okay, yeah, that's a little bit better. I think that'll do. So Control and S to save. Let's save these label settings. So let's do the drop down here. We'll do save. Then we can go into the assets And I'll call this was a white label, wasn't it? So GM underscore and then white underscore 32 and save. Last but not least, we need a little green check mark that's going to indicate whether the level's been completed or not. To do that, what we'll do is we'll add the root. So with the level button selected, we'll add a texture rect. Let's change the name to check mark. And then somewhere inside the assets here, we have this green check mark, which I'll drag and drop onto there. In the stretch on the right hand side, in the scale, I'm going to click on keep aspect to keep the aspect. And then down inside the layout, we're going to find the transform and set the size of this actually to 20 and, well, it said 21, that'll do, and 20 in the Y. So it's a bit smaller up on the left hand side. We also need to offset this slightly in terms of position. So let's do 5 pixels in the X and 5 pixels in the Y and do Control and S to save. By default, what we'll do is we'll hide this check mark. So I'll do again, Control and S to save. So that's the visual part of the level button done now. What we can do is select the root node and add ourselves a new script. Now what we want to do is we want to set up being able to click on this level button. I'm going to select the level button on the top left hand side and just get the values up in the inspector. We want to go down to mouse here, and instead of ignore, what we want is stop here. So it is going to actually process some kind of GUI input. So I'll do Control and S to save. Then on the node window, what we can do is we can hook up the, where is it? GUI input, here it is. We'll accept the defaults here and hit connect. I'm going to actually type this so we get a little bit of IntelliSense because it's an input event. And what we want to do is detect whether we've actually clicked or not. So let's go to the project settings, input, and let's add a new input. And we'll add this one and call it select. And then let's listen for input, and I'm going to do the left mouse button and hit close and Control and S to save. So now we can say if event.isActionPressed select is equal to true, then we'll print selected. Doing Control and S to save then, let's just press F6 and run this and make sure that we can get some output when we actually click. So I can see down that I'm actually getting selected. And if I hold down the mouse button, nothing happens. It's only detecting the initial click, which is exactly what we want. So I'll do F8 to close that. Next, we need a level number. So we'll do a var, and that'll be a level underscore number. We're actually going to set this as a string here, and we'll set that equal to 99 by default. That will eventually be set when we instantiate these scenes from the main menu. What we can also do is write ourselves a function called setLevelNumber. And then we can use that then to set our level number variable. So just level number is equal to level number and Control and S to save. The other thing I'd like to do is change the texture if we click on the button. Before writing some code here, I'm just going to close this output window so that we've got a little bit more room. So we can create a new constant up here. I'm going to call this a green texture. And then we can set this equal to, and we want to preload, and we want to preload the green panel here. I'll make it a little bit more room there so you can actually see this. That's a little bit better. Then also make a little bit more space as well. What we want to do is we want to set this texture on the 9-patch rect when we actually select the button. So what we'll do is we'll just do texture, which is a property that's part of the 9-patch rect, and set that then equal to the green texture. We can then do Control and S to save, and let's actually just do F6 and check that that's working as well, and it is. Now the moment it stays green, it doesn't go back to blue, but that's okay because in the game when we actually select it, we're going to then be loading a level, so we won't be seeing this again anyway. So I'll do F8 to close that. Then what we want to do is we want a reference to the check mark and also to the level label. So let's drag and drop these in so that we can actually make this on ready. And when we load up inside the ready function, what we're going to do is we're going to set the level label text equal to our level number. Control and S to save. Now I think I've already defaulted the level label to 99, haven't I? I can't remember. Yes, I have. So let's change this then to 22 just to make sure that this is working okay as well. So Control and S to save, F6. Let's have a look at what we have. Yep, that looks okay. So I'll do F8 to close. For now, that's all the setup we actually need to do for our level number. Obviously, when we click it, what we want to do is emit a signal saying that we've selected a level. But in terms of the rest of the functionality, that's pretty much it. Okay then, so let's make our main screen. Let's go back to 2D view. Let's make a new scene, other node, and this will be a canvas. Let's change the name to main before doing anything else, and Control and S to save, and then up to the root of the project, create a folder and main and save. I'll zoom out a little bit so I can actually see everything on the screen. There we go. And then what we can do is add our first node, which is going to be a texture rect. This is going to make up the background here. So what we can do is drag on one of the panels that I've got down here. I'm going to drag on the grey one, I guess. So I'll put that onto the texture rect. We want the texture rect to be anchored to fill the entire screen. So we'll do that. And then on the right hand side here, what we can do is go to tile instead of scale. And what that should do then is tile that texture throughout the occupied space. We can do Control and S to save. Then we want is to select the root node, grab hold of the favorite container here, or favorite node, which is the margin container. So I'll change that name to MC. And then inside here, what we want is a VBox container. And we're going to put a label at the top and then a grid container at the bottom. The margin container needs to be anchored to the full screen. And also the VBox container, if we go to layout on the right hand side, that needs to be set, no, it's not transform, it's container sizing. That needs to be set to fill in the horizontal and also fill in the vertical as well, which it is. That's good. For the margin container itself, let's add in some margin as well. So I'll add 24 pixels all around, I think. And now if we select the VBox container, we should see that it's indented from the edges of the screen. So we can add in our label then. So that's going to be our title label. We'll call that Sokoban, I guess. And I think I put ish on the slide, so I'll leave ish as well, Sokoban ish. Then we'll do horizontal center, vertical alignment also into the center. Then what we'll do is make ourselves some label settings for the title here. So let's load up the Lucky Sky font from the assets. Where is it? Here it is. And then we'll put the size here, I think 96 or something like that. Really, really big. There we go, Sokoban-ish. Then going down to the outline as well, we're actually going to make quite a big outline here. Let's do something like 18 pixels. And then adding in a color here as well, I'm going to add in 5E61D9. And I've got a feeling I might have made the outline a little bit big. No, that looks okay, actually, that looks all right. Okay, so we can save these label settings as well. So let's go to save. And we'll save these then inside the assets. And this can be LG underscore title underscore and 96. So we know what it is. Control and S to save. Then inside the VBox container, we also want to add ourselves then a grid container. And this grid container is then going to contain all of the level buttons. Going on to the layout on the right hand side here, what we're going to do is go to container sizing, and it's set to fill horizontal. We're going to expand this in the vertical, and you can see there we've now got this orange box filling all of the vertical space. So I'll do Control and S to save. So if I press F6 now to run that, we're not going to see very much. We should see a title and the background, but we will shortly have all of the level buttons placed on here. Let's close that down. One last thing we can do is quickly test how that's going to look with the level buttons. So I'll close the output window for some space here. Then what we can do in the grid container is just instantiate then a level button and see how it looks. Now you can see here that it's filling the entire container. That's because I need to go to grid container and set up 6 columns instead of 1. So that does that. What I'm now going to do is just duplicate these a little bit. And we're going to end up with, and we can see the effect actually, we're going to end up with 5 rows here eventually. Okay, that's exactly the look that we're actually going to be going for. So we're going to end up with basically 30 levels that we can choose from, and it's going to be looking like this. The other thing we could do as well with the grid container, if I scroll up a bit, is actually also just have a look at the spacing as well. I think there's theme overrides here, constants and horizontal and vertical separation. If I set those to 8 pixels, how does that look? That doesn't look too bad, maybe 10 pixels. Yep, that looks a little bit better. So I'll do Control and S to save. I know now that the grid container is the right size in terms of what we want. So I'm going to select all of those level buttons and just delete those because we're going to generate those dynamically from code. So I'll hit OK, Control and S to save. And in the next video, what we can do is create ourselves a script and actually load up these level buttons. Okay then, so what we're going to do now is actually create the level buttons from code. So let's make a new script, attach this to the main here. What we're going to do at the top is add a constant for our button scene. So we'll say const and button scene, and that's going to be a packed scene. And then we can set that equal to, and then we're going to preload and then find our level button inside here. So I'll drag and drop that in there and do Control and S to save. Next we'll have const level cols is equal to 6. And then we'll do the same thing also for level rows and set that equal to 5. We're not going to need anything inside the process, so we can delete the process. And what we want to do is create a function called setupGrid. Now we're simply going to loop through all of the levels that we have. So we can say for, and we'll say level in, and then we want range. And here we just want to do level cols multiplied by level rows. Now this will be 0 indexed, remember, so what we need to do is add 1 to the level when we're actually setting this up. So what we'll do is var, and I'll do LBS for level button scene is equal to, then let's take our button scene dot, and we want to instantiate this scene. Once we've instantiated this scene, we need to call our function on it. So I'll just go back and check inside level button what we called it again. It was this set level number, wasn't it? Okay, we're calling that before we're adding it as a child. That means the ready won't have been invoked yet. That's only invoked once it's added as a child. So we're able to set this level number before the ready actually gets invoked. So what we can do then is we can say that you've got the LBS dot and set level number, and remember we also need a string here. So we'll make a string, and that'll be then the level, and we need to add 1 to the level. Once we've done that, we need to add this to our grid container. So I'll go back to the main scene at the top here. We need to get access to the grid container. So let's drag and drop this in. Where do we put this? I'll put this actually above the constants, I think here. It makes it a little bit, for me anyway, easier to read. So I'll take the grid container then, and we want to do grid container dot, and then we want to add child, and we'll add child the LBS. Control and S to save. Finally, we can grab the setup grid and drop that inside the ready here, and Control and S to save. What we could do actually is make sure the level number is correct when we're actually selecting it. So let's go back to the level button scene, and down here when we've got selected, we just do a colon here, and then what we can do is we can also put the level number, so we can make sure that when we click it we are selecting the correct level number. So Control S to save, back to main, into 2D view. Hopefully that's all working okay. So let's do F6 and run this. And we get some level tiles on the screen. That's brilliant. So let's click 15 and we get 15. That's good. Let's click 17. We get 17. That's good. Let's click 4. That's good. They're all staying green. That won't matter because in reality, we'll actually then go straight to the game when we've clicked the button. We've got selected 1, selected 19. So that all seems to be working okay. I'm going to do F8 to close that and now do F5 and actually select the current scene as the one that I want to run when we run the game. So select current and now should run as normal as we've just seen. Excellent, that's really good. So F8 to close that. So our main scene is now up and running. We've got the level buttons working to go into the level. Now what we've got to do is actually load up the correct level information. Okay then, so with all of that up and running, we should now be in the position to be able to set up all of the navigation. To do that, we're going to need to add a couple of singletons into the project. So I'm going to right click and new and script. We're going to need a signal manager. And then we're also going to need a game manager as well. So I'll do new and where are we? Script, here we are, and game manager. What we can do then is we can go to project and project settings and into the auto load and click the browse button. Then we can drop into the singletons here, load up the signal manager, and then click browse again and also load up the game manager. I'll put the signal manager right at the top there as well, just in case any of these need to use signals later on. Click close, Control and S to save. Let's drop into the signal manager. We can delete both of these functions here. What we need to do is add a signal for when a level is actually selected, because then we need to switch out the main scene for the level scene. So we'll do signal and on level selected. That'll take in a level number, which I'll call LN for short, and that can be a string. What we can do then is we can actually open up the level button. You might have it already open, I'd closed it. And down the bottom here where we've got the selected for the level number, we can actually emit the selection signal. So we'll do signal manager dot on level selected dot, and we want to emit that signal with our level number. Next, what we want to do is set things up inside the game manager. So we'll open up the game manager. We don't need process, but we will need the ready. So what we can do is hook ourselves up to this on level selected. So signal manager dot on level selected dot connect. We obviously don't have the function, but we're about to make it. So we have on level selected, and then we can do func and on level selected. When we invoke this function here, what we want to do is actually switch level, which means we need the level scene. So I'm going to do const, and I'll call this level scene. And we can preload that. So we'll do preload, and then somewhere down in the assets here, we've got the level. So I'll drag that in across like that to Control and S to save. Let's repeat that process also for the main scene, because we're going to need to come back. So we can also then put in the main here and the main here and Control and S to save. I've just noticed, and therefore you probably have, that I've used const here, and I think in previous games I've used var. Const is used usually when you have something where you intend not to change the value, so that if you accidentally do, then the program will shout at you. I can't really explain to you why I tend to use var for these. It's more, I think, just out of years of habit than anything else. Obviously, you can use whichever you like to use. In this case, it's not really going to make much difference, because if we do modify one of these in the game somehow, then the game obviously is going to completely break and we'll see it anyway. What we can do though, speaking of vars, is make ourselves a level selected var. The reason for this is simply that when we select a level, we're going to obviously replace the main scene with the level scene. The level scene then needs to know what level was selected so it can load up the correct data. Now that we have this set up, we can actually set up the navigation. So when we have the on level selected, what we can do is we can say that the level that was selected is LN, and then we can do our get tree, change scene to packed, and the level scene. Then we can write the function that we've written a lot, which is load main scene. And in here, we want to do the get tree, change scene to packed, and we want to change to the main scene in this case. So with that written, we can do Control and S to save. So we click on a level button that invokes this signal here. We're connected to this. This should then load up the level scene for us, and we'll have cached in the game manager which level we actually selected. What we need to do now then is set up inside the level actually the ability to go back to this main scene and also then to set up the level data. Before we do that, I want to check what we used for exit, or what it was called. So project settings, input map, and it's called exit, the input action with the Q key to actually invoke that. So let's go then into the level scene. So I'm in the level.gd here with the level scene selected. Let's also first of all go into process. So we'll say if input is action just pressed exit equals to true, then game manager load main scene. Let's scroll down to where we're loading up the level data. I think that was hard coded here as a 2. So what I'll do here, just because of space reasons actually, is I'm just going to make a new var. I'll call that LN, which will be our level number, and get that from the game manager. And as I do that actually, I'm seeing that we're going to have to do this, and I don't really like doing that. So let's go back to the game manager and actually write ourselves a little getter function to actually get the level selected. So we'll do func get level selected. And in here then we can return our level selected. Control and S to save. Let's go back then into the level.gd, and now instead of that, what we can do is delete that and do the get underscore level selected. That's a little bit better. And then we can take this LN and put it in here. Now, of course, you could just directly put this code here inside the brackets here. I just didn't want to go off the right hand side so you couldn't see the code, so I'll do it like this. That should be everything, I think, actually set up. So I'll do one more Control and S to save. And now what we can do is hit F5 and actually see if we're able to navigate to a level or not. So I'll click level 1, and there's level 1 loaded. That's good. I'll click Q and we're back. Let's try level 2. That looks good. Level 3, that looks good. Level 4, that looks good. That all looks pretty good to me. We seem to be loading up different levels. Oh, I saw one there actually. That's good. Where we've got the green box already on a target here. That's nice to see. And let's try this one. That looks good. This one, that looks good. That looks good. We might, at the end of this, actually be able to zoom this whole thing in a tiny bit inside the level as well, because none of the levels seem to be filling out the screen completely at all, do they? So we could probably zoom the camera in a little bit. We'll have a look at that later on. For now, I'm pretty happy with what we have there. What we need to do now is we actually need to put a bit of UI in the game as well. Okay then, so what we need to do now is make a little bit of UI for our level here. So what we can do then is make a new scene, and this will be a user interface, and I'll call this HUD, H-U-D. We can do Control and S to save. Let's go up one level, make ourselves a new folder called HUD. This one will be relatively straightforward. I think we just want some labels in the top left-hand side. Next, we'll add in a margin container. So we can add a margin container here. We're actually going to stretch this one across the top of the screen. So for the anchoring here, we can do the top wide anchor preset here. Then as the theme overrides here, what we'll do constants is we can do the margin left, let's set to 12, the margin top to 12, the right doesn't really matter here. We can do then inside here is we just want some labels, so we'll make a VBox container for our labels inside here, and then what we want is an HBox container. Then to this we can add a label. That label then for text can have the level number. And in the label settings here, we can load up some settings that we already have, which is this GM white in here. Then I'm going to duplicate that label and call this one the level label. Now what we want to do here is we want a little bit of separation between this one and this one. So what I'm actually going to do is take the first label and go into the layout, and somewhere there will be custom minimum size, and in the X I'm going to put 120 pixels, and that moves out like this. That actually looks a little bit far, doesn't it? So let's do 100 pixels. That's good. For the level label then, let's set this just to 99 for a bit of a placeholder, and then let's select both of the labels and we'll do vertical alignment center. We'll leave the horizontal alignment for both of them to the left. We need the same also for the moves and also for the best score as well. So we'll duplicate this horizontal box container twice. Then I'll change this label here to moves. So that's the current moves taken. Here we can put this as moves label instead of level label. And then the next one, this label here can be best. And here what we'll do also is just put, we'll leave them all as 99. And then we can change the name of this one also to the best label. Next, what we can do is we can actually display this inside the level. So we'll go into level and we'll add in a new canvas layer. And on this canvas layer, we can instantiate then our HUD. So hopefully our HUD has appeared on the game there, and it has. I'm going to do now is I'm going to press F5 actually just to run the game and see if that looks too big or too small or how it's looking. So let's go to level 2. Yep, that looks about right. So I'll close that down. Now what we need to do is we need to go into our HUD and we need to add ourselves a script as well to be able to update all of the values. When it comes to updating this HUD, we're actually going to do things the old-fashioned way. We're going to couple this to the level scene. Usually, of course, I would use signals to do it so everything's decoupled, and I hope throughout the course so far you've realized the benefits of using signals and a centralized signal manager. Nevertheless, I thought just for practice on this course, it might be good just to see it done in the way that's often shown, I think, in sort of beginner materials for Godot. So rather than using signals, we're going to write some functions which will then actually be called from the level directly on the HUD, and then that will be then updating what we need. To do that, what we need to do is we need to grab hold of our labels. So let's get hold of the level label, the moves label, and the best label, and control drag those into the top here. So we've actually got them all. And then I'll write a new function called setMovesLabel. And here then we can get the moves label .text is equal to string moves. Then we'll get another one which is setBestLabel. We'll change that to best, and we can change that to best. And then last but not least, what we can also do is we can set up the level label. In this case, the level will be a string. Finally, we'll set up one more, and that will be a game over. So we'll do func and game_over. And in here, all we're going to do simply is hide. So we're going to remove ourselves when the game is over because we're going to be showing a game over UI. In writing those functions, I've realized here that I should probably technically put the return type, which is a void on the end of here as well, something I can easily forget and probably have done a lot throughout the course. So Control and S to save, and that's our HUD set up. We're going to invoke all of these functions actually directly from the level scene. So let's go back over into the level scene then, and at the top of the level scene, what we need to do is control drag our HUD into here. What we can do then is we can go down into the process function, and every time the process function runs, what we want to do is make sure that we've updated our HUD with the current number of moves. So we can do we can get hold of our HUD and do set_moves_label, and then we can send in the total moves that we've made. So I'm going to do Control and S to save. The other thing we can do is when we set up the level as well. So let's scroll all the way down into the setup level here. So when we're doing that and we've moved the camera, we can also do the HUD, and we want to set the level label, and we want to send in the LN like so. The best we'll deal with shortly. So Control S to save. Let's do F5 to run this. And what we should see is that the HUD is up and running. So I'll go to level 1, and we can see now that the moves indeed are increasing. The level doesn't seem to be correct though, does it? So let's come out of this. I'm going to drop back into the HUD. What have I done here? It's probably another spelling mistake. Yes, I was too quick there, wasn't I? That needs to be level label and not moves label. So Control and S to save. And whilst I see that, I've done exactly the same thing also for the best here as well, haven't I? So Control and S to save. Let's do F5. And let's do level 1. Okay, so now we've got level 1, move 0, and 99. And now hopefully if I move around, the moves are being updated, which is good. So I press F8 to close that. The next thing we need to do is we need to actually show something when the game is over and the number of moves we actually took as well. Okay then, so what we're going to do now is we're going to make sort of a UI that appears when the game is over. That's going to say how many moves we took. It's also going to put up a red label if we have a new record. So let's go into 2D view because I find it obviously easier. Let's make a new scene, and this one will be a user interface, and we can call this game over UI. We'll do Control and S to save, make ourselves a new folder for that and save the scene. Close down the output window there, otherwise can't see anything. So we're completely anchored to the entire screen. That's good. What we're going to do is going to add a texture rect onto here, and we're simply going to overlay that on top of the game when we've completed the level. So we'll do texture rect. We want this to expand and fill the entire screen as well, and we need to find ourselves something to drop inside here as well. So where are the assets? I can't find them because I'm in the wrong sort. There we are. Inside here then, I'm going to drop in the purple one. Why not? So we'll drop that on there, and then we can go to tile and have that tiled and do Control S to save. What we're going to do here then is add a margin container, because favorite node. So margin container and MC. This needs to fill the screen as well, so we'll anchor this to the entire screen. And in theme overrides here, I'm actually going to put quite a big margin here, 64. The reason is we're going to put a 9-patch rect inside of this, which is going to be basically a panel. So let's add a 9-patch rect inside here. I'm going to shorten this to NP as well, just for later on, and then scroll this up. And which one we can use this panel beige here. So let's drag and drop that onto there. We can see that there's something's gone wrong with the edges. That's why we're using a 9-patch rect. So we'll go to patch margin and let's set 10 pixels all around so that we have our nice edges for us on our panel. So what we want to do now inside here is add a vertical box container. So we'll do a VB for VBox container, and this can also fill the parent as well. And then inside here, what we want to do is we want to add a label. So I'll add a label inside here, which will be our title. So we'll call this level complete. And then the horizontal alignment center, the vertical alignment center, then label settings we can load up in our assets and our title settings that we have here, which is okay. Now that is pressed up right against the 9-patch rect, isn't it? And I don't really like that. So let's go and add in another margin container inside here. We'll change that name also to MC so we can actually see things. Let's make that one full rect as well. Then what we can do is we can grab hold of the VBox container and we can actually drag that inside the margin container. And now we can do is select that margin container, go to theme overrides constants, and we can put a little bit of margin around this as well, maybe 24 pixels. That's a little bit better. So back into the VBox container then, I'm going to duplicate this label. So we've got another one, and just put now XXX moves taken. Obviously it's much too big here. So what we can do is we can go to our level settings and we'll make these unique. And then what we can do is go down to the font size and maybe drop this down to 48, something like that. That looks okay to me. I'm wondering if we should change the color or not here. Maybe we can. So I'll scroll this down a little bit and just let's make this. Oh, that looks randomly chosen. 72 FFFF. That seems to be okay to my eyes anyway, but you'll gather by now I'm not really the best designer. I'm not going to save these label settings, but what we can do actually is change the name here to moves label. What we can do then is duplicate this and call this one record label. Then the text can be a new record with an exclamation mark. And for the label settings here, what we can do, I think if we adjust the color of this one now, we adjust both of them, I'm pretty sure. Yep, we do. Okay, so I'll put that back there. So I'm going to go to label settings here and make unique again. And then in the font here for the color, so that's sort of gone nice. I wanted a red color somewhere. Here we go. We've got some sort of red here. That'll do. Okay then, so the hex value that is, I genuinely can't see. It's actually completely cut off and I can't see it either. Let me try again. Okay, it's FA9578. Okay then, so we have our labels on here. What we need to do is sort of distribute these out in this vertical box container. So we're going to do something we've done before, which you've seen, which is basically just to stick a control in there. We'll call that a spacer control. And then what we're going to do is go to the layout here, the container sizing, and expand in the vertical direction. Then we can duplicate one of these and drop it there, duplicate another one, drop it there, duplicate that one and drop that one in here as well. And I don't like that one as soon as I see it, so I'm going to do Control and Z and undo that and leave the level complete up there and delete that spacer. It still doesn't look quite right on the top, does it? So let's go to the margin container and let's do margin top maybe 48. I think that looks a little bit better. Okay, Control S to save. There's no reason to fiddle around with that too long, is there? So we haven't hooked everything up yet, but just to finish this video, what I'd like to do is show this UI when the game is actually over. So what we can do is we can go to the level here, then inside the canvas layer, we can instantiate our game over UI. What we need to do is hide our game over UI. We'll leave this HUD working and do Control and S to save. So let's go into level and then into script view. We're going to grab ourselves a reference of the game over UI. And then with our game over UI, what we want to do is actually show this when the game is over. So let's scroll down and find where we actually find the game over. It's check game state. So here what we can do is game over UI dot and show, and then we want to do the HUD and hide. And now that I see that, let's go into the HUD scene actually. And that means probably that we don't actually need to do anything with this game over at all, do we? So we can just delete that function from there. So back into the level then, I just want to double check this is okay. We can delete the game over because that was working. We should then get our game over UI. So I'll do Control and S to save. Let's press F5 to run the game. Let's select level 1 because even I can complete this one. So put the box there, put the box there, put the box there, and hopefully we get the UI. And we do, level complete, XXX moves taken because we haven't hooked that up yet, and a new record. So the game over UI is now working. If I do Q, I should go back to the main menu and be able to drop back in here again, and we're reset back to normal, which we are, which is exactly what I wanted. Okay then, so we're nearly there. I've saved the best part though till last, and that's actually the persistence of the scores for each level so that we can show on the main screen whether we've completed a level or not, and we also during the game can understand whether we've got a best score or not. We'll start doing that in the next video. Okay then, so now we're ready to start writing the code to actually synchronize our scores to file. To do this, we're going to create ourselves a new singleton. So in the resources, in the singletons folder, I'm going to right click, new script, and call this score sync. Going to go to project settings, auto load, and find our score sync, add that in, and click close. Let's open up our score sync. So we're not going to need the process, but we are going to need the ready. We're going to save our scores to file. So we'll make a const and we'll say this score file and set that as a string, and that can be equal to then user and scores.dat. Another constant we'll have is a no best, and we'll set that equal to 10,000. That's a default no best score. The actual scores themselves we're going to store in a dictionary called best scores. What we're going to do is synchronize our best scores dictionary with the score file. The way the dictionary will be structured is really simple. If we complete a level, let's say we complete level 1, we'll add in the key 1, we'll put the number of moves, say 23, that we took in there, and then save that to file. That means the file will only contain the levels that we've completed. To do all this, we're going to need 4 or 5 sort of utility functions to be able to manage this all throughout the game. The first one, probably the most obvious, is to load the scores. So we'll do func and load scores. Here we need to check if the file exists. So we'll say if file access, file exists equal to false, then return. Otherwise the file does exist, so we can say var file is equal to our file access, and then we want to open, if I can spell this correctly, open our score file, and we want their file access and read. And then we can set our best scores is equal to, we get the JSON dot and then parse string, and here we want the file.get as text. Control and S to save. As soon as we load up, what we want to do is load this file. So I'll do load scores, Control and S to save. What we also want to do is save our scores. What I'm actually going to do here is just copy and paste this text and adjust it slightly as we need. So func save scores inside here, and then we can remove that because we don't need it. We'll do file access.open. Here we want to write, and then here we can do file and we want to store string, and it's json.stringify, which is the same as a JavaScript function, and our best scores. Control and S to save. So we have the ability to load and save the scores. Throughout the game, we're going to need to be able to ask a couple of questions. One is, do we have a score for a level? So we'll do func and has level score. This will take in the level then, and that's a string. Here we can return level in best scores. Next, we want a function to get level best score. Here we need to be careful. We need to make sure we have the level to get the score. So we'll say if has level score, level is equal to true, return best scores level. Otherwise, if that's not the case, then we'll just return our no bests. This will just be our default score that will show if we haven't actually got any score for the level. Next, when we complete a level, we want to understand if a score is a new best score. So we'll do func score is new best. And here we can actually copy and paste that line and say that if we don't have a score, then it must be a new best, so we can return true. Otherwise, we can say that if the get level best score for the level that we're sending there is greater than the moves that we've sent in here, then that means that we do have a best score, so we can return true. Otherwise, we'll return false. Control and S to save. So we can invoke this function wherever we want to ask if a given score for a given level is a best score or not. Finally then, the last function we need to add in here is to update the score information when we complete a level. So we'll make a new function called level completed. I'll copy the definition of this one to save a little bit of time. So we'll do level underscore completed. We don't need to return a bool, so returning void from here. So we're going to say that if the score is new best, then update the best scores. Note this returns true if we didn't actually have this level key, therefore we'll be adding in this level key into best scores here. Then we can save the scores, which I can see I've written without a space there, which isn't very good, is it? So let's scroll back up here and actually do save underscore scores, that's better, and go back down and save underscore scores and Control and S to save. That's all the code we need for the score sync. Now I don't want this video to go on too long, but I do want to give this initial test to make sure it looks sort of like it's working so that we can actually load up some information and actually save a best score. Let's scroll up to here where we actually have the load scores. What we'll do is we'll print here and we'll just print out the best scores when we load. So we'll print load scores so we know where we are, and then we can do a colon and print out the best scores. Initially we shouldn't see this at all when we run the game because we shouldn't have a file, so this will return from here. Now what I'd like to do is jump into the level scene, which is actually open here, and go into the level.gd script. Here we've got the check game state, and this is where we know that the game is over. Now we have a few things that we need to fix with the UI and the coordination of the labels and things like that. We'll do that in the next video. For now, what I want to do is just make sure that the scores actually sync. So we're going to get hold of the score sync, and then we can do level completed. The level that we have completed here is the game manager.getLevelSelected. And the number of moves then is the total moves. So we can do Control and S to save. So when we complete a level, we should now actually be saving a level score. So let's press F5 to run the game. And let's drop into level 1. So what I'm going to do then with level 1 is just go up, down a couple of times to take some moves and then complete the level, because even I can do this without failing. So we're up to 15, 17, 18, 19 moves. So we've completed the level there. I noticed in the output that we didn't see anything. So we didn't load anything from a file. What should have happened now though is that we have actually saved the file. So what I'm going to do is actually hit Q to go back to the main menu and then actually hit F8 to close this down. And now hit F5 to start this back up, and hopefully we see in the output the loaded scores, and we do. I can see that we've got the key 1 and also the best moves is 19. So let's go back into level 1 then. Let's actually take more than 19 moves now and make sure that we don't erroneously update the number of moves. So I'll complete the level again. Okay, I'm going to press F8 to close this, and now F5, we should see 19 still as the best moves, and we do see 19 as the best moves. So one last test is to go into level 1 and now complete it with the optimum number of moves, and then I'll do F8 to close this again, and now F5 to rerun it again, and we should see the lowest score as the best score, and we can see the 11 moves as the best score. Great, so that looks like we're actually coordinating the scores. Let's do one more test just to finish this video. I'm going to zoom through the level 2 and edit this for you. Okay, so that's that level completed. I'm going to do F8 and then F5 just to load this, and we should have 2 scores now. Let's have a look at the object that loaded, and indeed we've got level 1, 11, and level 2, 93. That's excellent. So F8 to close that. So our score synchronization is now working. What we need to do in the next video is tie all of this up so that we show the information in the UI correctly, we show the record label correctly, and also we show that little check mark on the level button as well if we've already completed a certain level. Okay then, now the score synchronization seems to be working, we need to actually sort of get the UI up and running. The first thing I'm going to do is go into the game over scene. So that's this game over UI here, and we need a script on this because I'm seeing we don't have a script. So selecting the root node, let's make a new script. Call this game over UI. In the game over UI, we want to be able to show and hide the record label depending on whether we have the record set when the game is over. So we'll control drag the record label into there. Then what we need is a function for when we start a new game, or we indeed reload the game inside the level itself. So we're going to func and call this new game. So in this, what we want to do is we want to hide ourselves, but we also need to make sure we hide the record label in case we've just been showing it. Then we want another function which is for the game over. So I'm going to do func and game underscore over. And then here what we want to do is we want to actually show ourselves, and now what we want to do is check whether we want to show the record label or not. So we're going to say that if our score sync dot, and then we want to check if the score is new best. For this, what we want to do is we want to send in a level, which we don't have at the moment, and also the number of moves. If that's equal to true, then what we're going to do is we're going to show the record label. So we'll take the record label and .show. As arguments into here, then we'll send in the level as a string and the moves as an integer. Control and S to save. What we need to do now is invoke both of these from inside the level scene. So let's go back to the level scene and in the script. And now instead of the GameOverUI.show, what we're going to do is we're going to do the GameOverUI dot, and then we'll do GameOver. And then we can send in the GameManager.LevelSelected, and I need to make, as usual, some space here so you can see this, and we'll send in the total moves as well. So to double check that then, we're hiding the HUD, we're showing the GameOverUI, and then we're deciding whether to show the record label or not. What we also need to do is invoke the new game function as well. So down in the setup level here, what we want to do is get hold of our GameOverUI, and we'll do the new underscore game here. Control and S to save. So hopefully the game over UI should now be working. So I'd like to check this. Before running the game, I'm going to delete the scores.dat so we can use the level 1 as an example to test this out. Otherwise it's going to take too long. So having deleted that, then I'm going to go back into the UI, press F5 to run the game. We don't need to get any scores loading, which is good. So let's go into level 1 and let's complete level 1. Let's do a few moves like this, up and down a few times, and then let's complete the level, and we should get the record label with the game over UI, and we do. Now what I'm going to do is press Q and go back to the start screen and go back into level 1. We still haven't set up the best here, we'll do that shortly, but now I want to set a bad score so that I don't beat the level 1 score that I just did, and see if the new record appears. So I think I'm definitely over the score here, so let's try this. Excellent, so we've got the level complete, XXX moves taken. We still need to set that up, but the important thing here is we don't have this record label being shown. So I can type quit and go back to the start screen. Let's press F8 to close that. There's something else I'd like to test out inside there as well, and that's the ability to reload. If we go to project and project settings, if we go over to input map, you might remember that we set, or at least I did, this reload up here where we can press R to actually reload the level. Let's go up inside the level.gd actually into the process somewhere, and we need to set up this reloading inside here. So we'll take this one here and we'll say that if input is action just pressed and we want reload, then what we want to do is we want to set up the level. Control and S to save. Let's test that out by going F5 to run the game. You can see now I've got 27 moves as the best score for level 1. So let's go into level 1. Let's just make a few moves and now hit the R key and see if everything resets. And the game is reset, but I've noticed that the moves level at the top there hasn't reset. So let's close that down and let's go down into level here, and somewhere in the setup level, I guess we're not setting the total moves, and we're not. So what we'll do then is right below the definition of these variables, we can set the total moves is equal to 0 and do Control and S to save. Let's try that again with F5. Do the 1 here, and now let's go up and down like this and press R to reload, and the moves is back to 0. That's really, really good. Now what I'd like to test out is the actual game over UI with this as well. So I'm going to go here and here and here. What's the record? 27. So this is, I'll just go a bit nearer the record to give a bit of wiggle room. Okay, so we've now set a new record. Now what I'd like to do is press R to reload the level, and we should be back to where we were, except we're not, because now the UI on the top left hand side isn't showing either. So let's close this down, and in setup level what we need to do is also make sure that we show the HUD as well. Now one thing you might have noticed here is the code is becoming a little bit bitty. Yeah, we've got the HUD stuff here, then the game UI here, and then somewhere we're checking the state of the game as well. This is a really good example of why I said what I did at the beginning of the course when we first did a signal manager. Once you start tightly coupling things together in this way, your code eventually is going to become very, very difficult to manage. And in fact, even with a simple game like this, I'm finding it now difficult to remember what we need to switch on and switch off to make sure everything's coordinated. It's much easier to separate everything out and use signals so that everything is encapsulated in itself. I'd much rather have just called these sort of game over functions and new game functions and things inside these scenes responding to a signal. So I'll stop ranting there and press F5 to run the game again. And let's go back into level 1. Let's make a few moves and just hit R to reload. So we're okay there, we're reloading. Let's make a few more moves. I don't want to do a record yet. I just want to check that we can at least reload the normal HUD. So level complete, let's press R to reload. There we go, the HUD is now there. Now what I'd like to do is make a couple of moves and now try and set a new record and see if that record has not included the previous moves before we reloaded. It shouldn't have done, but nevertheless it's worth checking. So now we should have a new record, and we do. So I'm going to quit out of there and just press F8 to close the game, press F5 to run the game, and hopefully we've got the record that is now 15. Good. Okay then, so that's updated as well. Let's press F8 to close that. So the HUD and the Game Over UI are now working. What's not working inside the HUD, of course, is that we're not showing the current best score. So what we can do is we can go into the HUD scene. Inside the HUD scene, what we can do then is we can add a function for a new game. So down the bottom here, we can do func and new game. We'll send in the level string as an argument here for the new game. And here what we want to do is we want to set up the best score label. So what we can do is we can say set best label, and then we want to get hold of our score sync. And here it's get level best score, and we send in our level and Control and S to save. Now we can also set the moves label here as well to 0. It'll be set almost instantly because it's done in the process inside the level.gd. Nevertheless, we can set the moves label as well. And what we can also do is set the level label. So we'll do set the level label and set that to the level. So Control and S to save. Now we have this new game function. We can go back into the level scene. And now where we're setting this level label, what we can do instead is we can just call new game. I can also see that we're calling this show on the HUD here. So we can also delete that line from here, go back into the HUD, and we can also write show once all of this is set up, and Control and S to save. Let's go back into the level scene just to double check that. So every time we call setup level, which is with a reload, what we should be doing then is calling that new game, which gets all the best scores and everything, and then resetting to a new game on the Game Over UI as well. And then when a game is over, which is in the check game state here, we do the Game Over UI, we hide the HUD, and then we sync up whatever score we've done. That should then be everything we need actually to have the in-game HUD working. So let's do F5 and see if we can actually get this to work. So I'm going to go to level 2 this time. So we've got the best 10,000 here, which means effectively no best. We've got level 2 and move 0. So let's actually try and set a score here. I'll fast forward this so you don't have to get bored. So I've set a new best score. It's deliberately not a best possible score because I want to make sure we can set another record. What I'm going to do now is hit the R to reload and start the level. And that's excellent. We can see we've got the best 113. That's what I wanted to see. So I'm going to do it again. So now I think I've set a record of 93. So I'm going to reload again, and that's good. So now we can see the best of 93 on here. I'm going to do this once more and go above 93 and just double check that it doesn't update that incorrectly. So I think we took 99, so and we should still see 93, and we do. That's great. So if I quit back to the main screen and go back into level 2, we still see the 93. If I do F8 and then F5 to run the game again and go into level 2, we should see the 93. Excellent, we do. So I'm going to do F8 to close that. We've got one more little cosmetic thing we need to do on the main screen, and that's that checkbox with the level button. So let's open up the level button scene. So inside the level button then, what we can do is when we're ready to be displayed in the scene, we can also see if we actually have a score. So we can say that if, and we want our score sync dot, and it has level score, we can send in our level number. If this is equal to true, then we want to show the check mark. So we'll do checkmark dot and show and Control and S to save. So let's do F5 and see if we now get a couple of check marks on the screen. And we do. We can see we've got a couple of check marks here to indicate that we've completed the level. I'm going to go to level 4 and complete this and speed the video up just to double check that when we return we get another check mark. So I've completed level 4. Let's go Q back to the start, and I can see great that we've got a check mark on level 4. Let's do F8 to close and F5 to start again. We should have a check mark on level 4. And if we go into, and we have, and if we go into level 4, we've got the best number of moves as well. Good, so we're very nearly now to actually a finished game. That's all of the score synchronization set up.